Most people try to learn backend development by jumping straight into random tutorials, copy-pasting code, and hoping it somehow clicks. Others avoid backend altogether because they think it's too complicated. Servers, routes, databases, it all sounds very overwhelming. Today, I'm answering one of the biggest questions beginners ask me. What do I actually need to know to build a real and secure backend with Node.js and Express? Here's the thing. Once you understand the right fundamentals, routing, middleware, validation, authentication, everything suddenly becomes simple. And building real REST APIs stop feeling like magic and starts feeling logical. So in this video, I'm going to teach you how to develop a REST API the way it should be learned, step by step, by building an actual project. A movie watchlist REST API tested in real time using Requestly. By the end of the video, you'll know how to structure an Express server, create routes, connect to a database, add authentication and authorization, validate requests, and so much more, all with clean code and best practices. And the best of it is that we're also going to deploy our REST API so that anyone around the world can access it by using Hostinger. Now, before we get into the video, if you're looking to learn NextJS in a beginner-friendly and structured way, check out my new Next Level NextJS course for beginners. It is the best NextJS course you'll ever find. Just go to www.webdevotra.com/nextjs or click the link in the description. And now that we got that out of the way, let's get started. Okay, everyone. So to get started, let's create the folder that is going to contain our entire project. So I'm going to create here a folder called Backend Course. You can call it whatever you want, but we're going to be creating an API inside of it. And I'm going to drag and drop it inside of the code editor of my choice. In this case, it's going to be I'm using VS Code. Now, when you want to set up a Node.js project, what you need to do is first create a package.json in your application. Now, to do that, you can just run the command npm init-y. What this will do is it is going to create a package.json file that is going to help you configure your entire application. It is going to be the file that is the blueprint of every Node.js project that you have. It's going to list out the dependencies that you have installed into your project, meaning external libraries and so on, any scripts that you might want to run with your API, and some basic project info, for example, the name of your API, the version, the description, keywords, and so on. Now, we're going to be touching on this a little bit more later, but what we want to do now is create the structure of our app. So I want our entire API to be inside of this folder called the source folder. Now, the source folder is going to contain the source material for our API. So we're going to have a bunch of folders inside of here to organize how our code is going to look like. But the entry point of our API, meaning the file that is going to create our server and start our app, is going to be a file called server.js. Now in here, we're going to create our API, listen to it in a port, and basically manage the entire app from this file. Now, there's just a couple things we need to do first before we continue. So we want to install a couple packages. And you can see here in our package.json that there is no keyword for dependencies, which, like I said, are external packages that you have installed. Now, these packages that we want to install are going to help us in a variety of different ways, and I recommend you having them in every single API that you create. The first one is the Express library. So I'm going to install here npm install express. Now, most people get confused with the difference between Node.js and Express when they first start building their REST APIs. However, Node.js is not just for building APIs, actually, it's for everything in the JavaScript ecosystem. It's for running a JavaScript server. And Express is a framework, a JavaScript framework that helps you build easier APIs. So you could build an API using just Node.js. However, in today's standards, it is recommended that you use a powerful framework such as Express. So we're going to install Express, but there's a couple other things that we do need to install as well. For example, we want to install this package called NodeMon. Now, it's going to be a developer dependency, and there's a difference between them because NodeMon only helps you in development. Express will help you in production as well. So I'm going to just install Express, and then to install a dev dependency, what I need to do is I need to run npm install. Then you put the name of the dependency, which is NodeMon, and you put /save dev. And you'll see that in our package.json, Express was installed in the dependencies list, and dev dependencies list includes NodeMon. Now, what does NodeMon do? Well, when we start building our API, it will become clearer because what it does is it helps you develop your API easier by making it such that whenever you save a file in your project, it is going to automatically restart your server and reflect the new changes. If you don't have NodeMon, you'll have to kill your server and rerun it again every time you make a change in order for the change to be reflected. So we do need NodeMon no matter what. So now what we want to do is the following. In the server.js, we are going to do everything from creating our app, listening to the port, to connecting to our databases when we do eventually get there. Now, in order to create our app, we're going to import the Express package. So I'm going to use require to import, and I'm going to import the Express package. Then what we want to do is we want to create a variable called app. And this app variable is going to be the instance of our app that we're going to have. We're going to set that it equal to express and call the express function that we just imported. Now with the app, we can do a bunch of things. Now with this app variable, what we can do is we can initiate the server by listening to a specific port. Now, a port is just a place in your own computer server that you can associate this project with, so that when the server is running, it will be running on that specific port and not on some other port where another app is running. So you have to pick a port that there's nothing running in your computer. Now, I recommend, at least for this project, to run on 5001. That's what we're going to be using, but there's a bunch of other famous ones, like you can run on 8080. A lot of front-end projects run on 3000 and so on, but I'm going to run on 5001. Then, to make your server listen to this port, you're going to create a variable called the server, and you're going to tell the app to listen to that port that we just created. Then this listen function listens to the server, and it allows you to put here a callback function that will run whenever the server successfully initiates on this port. So in here, you can do something in that case. What I want to do is I just want to console.log a message so that whenever we run this command and run the server, we know that it was successful. So what I want to do is I want to say server running on port, and then I'll just insert whatever port we have over here. Perfect. Now we don't need to really do anything with this server variable over here. Just because we're listening to the port over here, this should be working. Now, how do we run this? Well, I can come over here into our terminal and I can run node and then go inside of the server.js and I can do source/server.js. You'll see that it will console log the message server running on port 5001. But you also notice that it stops running immediately, and whatever changes we make here, whenever I save the file, doesn't really restart the server. What I'm going to do for now is I'm just going to delete this over here. You see that if I run this again, it will still do the exact same thing. But if we were to utilize this package that we have installed called the NodeMon package, we can create a script in our package.json that we can run in order to make it such that when we run that script, it is going to restart the server whenever we make any changes. Now, scripts work in the following way. For example, this test script over here, it comes when you install the package.json file, and all it does is it just literally messages this, no test specified. But to run that script, what I would have to do is just run over here npm run and then put the name of the script. In this case, it's just a test script for you to test it out. You see that you get this exact message that they put over here. So for us to create a script that is going to run this NodeMon package, all we have to do is give it a name. Now, since this is just going to help us in development, I'm going to create a name for a script called dev. Then we want to call the NodeMon package and kind of run the server like we did over here. But instead of using node, we use NodeMon. So I'll copy the entry point of our server, which is the source/server.js file, and I'll put it there. So we're just running NodeMon on this file. Now I can just run npm run dev, which is the name of our script. And you'll see that it is actually running our server, and it has a bunch of other console logs, which means that it is from NodeMon. Now you see that if I just command S on our server here, it runs again, and it will run as many times as I save my file. Now right now we have nothing on our API, so it's kind of hard to test, but you should be sure that this is restarting every time we save the file. Now to start things off, before we move anything forward, I want to teach you guys how to make your first API endpoints. Now, as you might know, API endpoints are specific URLs in our server where clients like front-end projects, people who are just using our API will send requests to our server to perform actions such as getting data, creating data, updating and deleting data. Now, there are different types of API endpoints you can make. When you're trying to get data, you would utilize a specific method that represents that action of getting data. Now, the different methods are also known as HTTP methods, and there are a lot of them, but the main ones are the get, the post, the put, and the delete. But there are other ones such as patch, for example. But in this video, the main focus is for what you use for 99% of the time, which is just the get, post, put, and delete. Now, in order to make your first API endpoint, we're going to make a get request. What we're going to do is, before we listen to the app, we're going to call the app and say app dot, and then you can define a specific type of HTTP method. So we're going to make a get request. I can just put here a app.get. Now, when you do that, you can specify here a specific path to this endpoint. Now, what does that mean? For example, we are running our project on the port 5001. That means that our project, if someone wants to reach our server, they're going to access it by doing http://localhost, because we're running this in our computer, 5001, colon. So this is how they reach our server. But there's going to be different methods in different parts of our API that we need to manage. So whatever you put over here is going to be what appears after the base URL, which is this over here. So for example, if I make this get request be hello, then to actually run whatever exists on this API endpoint, I have to make a request to the /hello endpoint. Now, I'm going to show you guys how to make that request. We're going to be using a very special software that can help you with this. And but for now, let's just build this out. Now, we defined that this is a get request, and we defined the name or the path name to that request. Now, what we can do is we can access a callback function over here that is going to run whenever someone makes a request to this endpoint. Now, in every single request that you have, you get access to two things, a rec and a res. Now, the rec stands for request and the res stands for response. They're used for different functionalities. The rec helps us request data that was sent by whoever made this request. So if someone sends, for example, if you're making an API request to register a user on Facebook, right? Facebook will get back that request, and the data that is sent from the client, from the front end, will be sent and will be present on this request variable. Now, the res stands for response. So it's what we use to send back data to the client. Now, over here, we're not really doing anything here. All I want to do is I just want to say res to send a response back. And when you call res, you can send back some JSON. Now, JSON, you might know at this point, it's a lightweight text format that will allow you to store and send data by using key value pairs, which is kind of like an object. Now, if you're not familiar with JSON, it's the basis of every single API nowadays, and you will get the hang of it as we move forward in this course. But the idea here is that we're sending back kind of like an object, and I can send back anything I want. I can send back an array, actually. I can send just a string. I can send whatever I want, but I'm going to send an object with a message, and it's going to say hello world. Now, to test this out, I want to make an API request to the localhost 5001/hello and see if we get back this object with a message saying hello. Now, how do we actually make an API request to this? You could obviously create your own front end and make the request to this, but we're not going to be touching front end in this video. When you're building your API, you can use an API client just like the one we're going to be using in this video, which is Requestly. Now, there's a couple options out there, but I highly recommend Requestly. A lot of people like to use alternatives such as for example, Postman. However, I think Requestly is better because it is a lot more lightweight. It is also locally controlled, and it is completely free for you to use, but they do have some extra features if you want to pay for it. However, the pricing structure for those extra features is better on Requestly. Now, we're going to be using Requestly. I'll teach you guys how to exactly set up the project for this. Now, the first thing we need to do is we need to create a workspace. I'm already on a workspace over here, but to create one, you have to click on the add button at the top. Now, make sure you install Requestly by using the link in the description. And when you do, just click add over here and give it a name. I already created mine. It's called Movie Watchlist Project because I am going to be using, that's the project we're going to be building, but you can create something like this and click on create workspace. When you do, you're going to be here on the APIs part of Requestly. Now, the first thing we need to do is we need to create what is known as a collection. A collection is just going to be a collection of different API endpoints that we're going to be using to send requests. Now, we're going to make one for this project as well. It's going to be called Movie Watchlist API, and we're going to create it. Now, the thing is, in here, we're going to put all of the different requests related to this API. But one thing we can do as well is we can set up a variable. Now, why is a variable important? Well, because no matter what endpoint we create, there's going to be one thing that is always in common. It's the like the base URL of our API. So we can copy this over here and we can create this base URL variable. We can call it base URL. It's going to be a string, and we'll put both localhost 5001 and both of them. Then we're going to click save, and the variables have been saved successfully. Now, how do we use them? Well, when we create our own requests, you'll see how to use them. I'm going to click here on new request, and we're going to create our first request. As a testing one, what I want to do is I want to create a request for the app.get/hello. So a get request for the hello endpoint. And to do that, I'm going to have to come over here and put the URL for that endpoint. We've already determined that the URL is this, right? It's this entire thing over here. But because we created the base URL as a variable, we don't have to always rewrite this localhost 5001. We can just insert the variable by doing this, by adding the two curly braces and inserting the base URL as the name of the variable here, and then just put the /hello to represent the extension that we defined here. Now, you need to choose what kind of HTTP method we are needing for this request. If you remember, we created a GET request, so we just leave it as a GET. Now we can give this a name. I'm gonna rename it to be test request because it's just the test request that we've been making. And we'll obviously move forward. Now, there's a bunch of stuff over here that we don't really need to worry about, at least for this request, because it's the most simplest request we can make. But what we can do now is we can click send and see if it works. It says that no routes were found. So it says that there's an error and that the route hello has not been found. Now, you might not have received this. You might have worked for you. I just realized I had another server running, and that's why this happened. I had another server running on the same port, but now I kill that. So what we can do is just click send again. Perfect. And as you can see, we got back the object with a message saying hello. We saw it over here as well that the status of this request was at 200, which means that it was successful. So we successfully made an API request to our first endpoint. And now it's time that we start learning about how to organize our project a bit better in order for us to create all of our other endpoints. Now, the reason why we want to do that is because we don't want to make all of our endpoints in the same place, right? We're using this app variable over here. We don't want to make all of our different endpoints here because then it just becomes a huge mess and everything is in one file. Instead, what we want to do is we want to divide our endpoints into categories. For example, in this project, like you saw in the demo, we're building a movie watch list API. So in this movie watchlist API, there's a couple different parts of it that are independent from each other. For example, there's the endpoints that are related to authentication. So like sign in and sign up. There's also the ones related to the movie, like getting all movies and so on, like all the kind of stuff. There's not a lot that we want to do with movies because this is more of like adding movies to our watch list. Then there's also users, right? Like how do we store information about a user, like profile and so on. And finally, there's information about the watch list. Like how do we add, we need to be able to add movies to our watch list. We need to be able to delete movies and so on. So as you can see, there are 4 different parts of our API that we want to separate from each other. Now, when we make an API endpoint like this, we separate those different parts of our APIs by creating routes. And routes are not only for organizing your project inside of your project, like putting in different files, but also for separating your API from each other. So for example, every single endpoint that we create for the auth is going to exist after the auth route, which is just a word you put after this. So like before we had the hello, instead of just putting everything as just one thing after the base URL, we're going to have first auth, and then every endpoint that we create inside of the auth we'll have over here. For example, we'll have an auth/login or an auth/register, stuff like that. Then for the movie, same thing. It will be movie/get or create movie, whatever we want to do. It will have this in front. And this is what is known as a route. Now, to create a route, what we need to do is we need to create a folder in our project called routes. And in here, we're going to create our first route. Now, the first route that we want to create is related to movies, because in order to add movies to your watch list, we need to have movies inside of our project first. So I'm going to create here a file called movieroutes.js. And in here, what I want to do is I want to define the movie route. I need to import express by setting this equal to require express. Now, before I even move any further, I want to point out something. If you are there's two different notations for importing packages in JavaScript. There's the require methodology that we've been using over here, and there's the import notation. Now, some people prefer a way or the other. It depends. I personally know that a lot of people who do APIs or do backend in JavaScript use the require. However, I believe that it's better to use the import notation. Now, the way in which you enable yourself to use the import notation is actually pretty simple. What we do is we first come here to our package.json, and you see how there is a type over here saying common.js. Now, we can allow this to be module, and with module, we can utilize the following notation. Instead of saying require, we can import express from the express package. Now, same thing with here. We can just copy this, paste it here, and you see that we won't have any issues. Now, the issues that appeared over here were from before I saved the file. You see that as I restart the server, there's no more issues. Now, let's continue. I want to create the movie route. So to create a router for this, we're going to create a variable called router and set it equal to express.router. Now, by creating this router, what I can do is I can, for example, say router.get, and it will allow me to make an API endpoint inside of this route. Now, we're going to do the same endpoint we had before, the hello route, just because you guys already understand what it is, and I'll do it really quickly here. I don't even need to have I'll get a request and a response, and I'll just do the exact same thing we did before, res.json, and then just send back a message that says hello. But I'll do this for now so that you guys really understand what a router is. Now, at the bottom over here, after all of our endpoints, now what I need to do is I need to export this router so that we can import it inside of our server.js. So at the bottom over here, I'm going to export default the router variable. Then in our server.js, I'm going to create here a part of our imports called import routes. And I'm going to import each individual route over here. The first one is going to be the movie routes. So I'm going to create here a movie routes variable and import from /routes/movie routes. So I could just import this, and this will be equal to this. Now, to apply a router that we created, what we have to do is the following. Before we listen to our API, but after we define the app, I'm going to create here a port, which is going to be called API routes. It's where we apply them. And for each individual route that you create, you have to call the app and call the use function, which we're going to go over it a little bit later when we talk about middlewares. But for now, just know that you need to use this use function. And to apply a router, you have to define the name of this route. For example, this is the movie route. So I'm going to have it be the /movies, right? That's the name of the route. That's what I was talking about, where now it has to be /movies/ whatever you put. And then you pass the router, which we just imported. Perfect. Now, this means that for me to make an API request to this endpoint over here, what we did before, where it's just base URL/hello, doesn't work. You see, it doesn't exist. What you need to do instead is you need to make a request to the movies route first, and then access the hello route inside of the movies route. However, it does say that there's an issue. So let me go back over here. Yeah, the issue is this. When we import with a type module and you're importing a file, not a package, it doesn't automatically add the .js in the end. So we do need to add the .js or else it won't work. Now, if we go over here and we click send, you should see that we do get that hello. But if we were to send it again with just the /hello, it will say cannot get /hello. So we are successfully making an API request with that route. Now we could make other routes in here as well. For example, I could make a get request with nothing in it, like no specific routes in here, just using the movies routes. And then I could make another one that also doesn't have anything. Now you might be wondering, how is it that we have two different endpoints with the same route, but they also are the same extension or the same path name over here? Well, you can do this as long as the HTTP method changes. So most likely you'll see something like this, where each route has a get, a post, a put, and a delete. Now, if you're not that familiar with how HTTP methods work, the get is for you to request data. So when the front end wants to fetch information from the server, like for example, get the email from a user in the database. The post is for creating data. It's where we're going to handle stuff like, for example, creating a user or adding a movie to the database and so on. Put is for updating. So it's for like when you want to update a user's email. It's not for adding stuff or deleting. It's mostly for just changing. And the delete, the name implies, it's for removing stuff in your own database. Now we can test to see how they work. For example, I'm going to put here I'll return an object in this one that says HTTP method. And in the get one, I'm going to return a get, and I'll put this on all of them. So you see how they differ. We're going to put one here, and then one here. We're going to change this to be post. We're going to change this to be put, and we're going to change this to be delete. And now what I can do is I can come here and I can change this to be actually I'll just run the get, but because we didn't put anything on the path name, we don't need to put anything over here as well. It can just be a request to /movies. You'll see that we're going to get a successful request saying that it's an HTTP method /get. Now, if I change this to be a post, you'll see that this will change to post. If I change this to a put, it will change to put, and to a delete, it will change to this. But we didn't make one for patch, so it won't work. So these are the absolute basics. Now, up until this point, we haven't done anything related to a specific database, but in this video, we're going to be using PostgreSQL as our database management system. Now you can use MongoDB, you can use MySQL, you can use anything else, but we're going to be using PostgreSQL, and you can have a PostgreSQL database being hosted for free on a website called Neon. This is not a sponsored video. It's not sponsored by Neon, but you can click the link in the description that I have, and it's an affiliate link because I really like them. You can just go in the description and check them out. Now we're going to be using Neon. It's completely free. We're going to create a database for this project. Now to create a Neon database, I want you to sign up to your account. I already have an account, so I am going to just log into mine. I recommend signing up with GitHub though. Now, when you're here, you want to click on new project and you want to give it a name. I'm going to call this movie Watchlist API. Then we're going to keep the Postgres version as it is. We're going to choose AWS, and the region is going to be AWS US West because that's the closest that I have to myself. But you choose wherever it's closest to where your users or the consumers of your API are going to exist. Now I'm going to click here, create, and it's going to create a project for us. So that quick, we already have a database. Now this database is completely empty. If I go here to tables, you see there's no tables over here. And we could create the tables by clicking here and just clicking create table, and then it will allow you to do that. But we're going to do it a bit differently. When you're dealing with databases and your APIs, it is highly recommended that you work with what is known as an ORM. An ORM is a tool that lets you interact with your database using good JavaScript objects instead of having to write raw SQL queries, for example. And that's great because a lot of vulnerabilities in your API comes from people back in the day having to write manual SQL queries. And nowadays with ORMs, you can do it super simply. You don't need to learn SQL or any other kind of language used for databases. You can just write everything in JavaScript or TypeScript inside of your API, and it will handle it for you. And there's a bunch of different ORMs that you can use. In our case, we're going to be using one of the most popular ORMs out there called Prisma. Now, Prisma has been around for I don't know how long, like so much time, and it's one of the best out there. So I recommend using them, and it's database agnostic, meaning that you can use Prisma for a PostgreSQL database, or for example, for MongoDB, whatever you want to use, you can use Prisma, and that's what we're going to be using. So I'm going to come back over here, and what we want to do is we want to set up the database in our project. To do that, I'm going to open up our terminal, and I want to first run the command npx Prisma init. Now, if you don't have Prisma installed inside of your computer, it's going to ask, do you want to install Prisma? And you press Y and press enter, then it's going to set up Prisma inside of your project. You see, it is fetching a bunch of stuff, and it's going to create the necessary folders for Prisma to exist in our project. Now it's finished, and you can see that what it did is it created a prisma.config, it created a Prisma folder, and it also installed, and it didn't install the Prisma package inside of our project. So that's something we do have to do. So to do that, I want to install two different packages. The first one is going to be Prisma. So to install Prisma, it's going to be a dev dependency. So I'm going to say save dev, and we're installing the Prisma, raw Prisma. But we also want to install another package called Prisma Client. And Prisma Client is going to help us have auto completion whenever we're working with our different tables. Now, to install Prisma Client, we do npm install prisma/client. Perfect. Now, as that's done, you'll see that we are ready. The prisma.config doesn't have any errors anymore because we installed the package, and everything is good to go. Now, in this Prisma folder, you see that there is a schema.prisma. And what this is a schema file for our database. Now, you might not be seeing this file with all of this syntax highlighting like I have, and that's because I have an extension installed. The extension I have is the Prisma extension, and I highly recommend installing it because you'll be able to read Prisma files such as the schema.prisma with a lot more ease. Now, one of the things that you need to do in order to connect your database that you created over here with your project is to connect it to Prisma. And Prisma makes it super easy. They allow you to create an environment variable called database URL, and you pass in the URL of your database so that it connects both of them. To access the URL, you go to the dashboard, and you see that here it has a connect section. You click on connect, and it has this beautiful URL that you can just copy. Now, where do we put this URL? Well, you see, Prisma requires that we have an environment variable called database URL that will contain that. Now, if you're not familiar with environment variables, they're just variables that we can create for our project that aren't directly part of our code. Now, why is that important? Because if it's something that is sensitive, such as, for example, the database URL or API keys and so on, you don't want to push this code to GitHub when you maybe send it to someone, or you want to publish it to be open source. You want to keep that hidden. So you create environment variables where, as you are running your code in development or even in production, it will work. However, it won't be visible to the client. Now, you see how it automatically created this .env file, and it put this variable over here. This is how a .env file looks like. It will contain variables with the name just like this, and an equal sign, and then a string to represent the value of that variable. Now, this database URL that they gave us here isn't the one that we want. We want to delete this and replace it with the one that we copied from Neon. So I'll just paste this over here, and we should be good to go. Now, in order to get the .env file to work inside of our Node.js project, I want to import at the top over here a new package that we haven't installed. It's going to be the .env package. So I'm going to install .env. Now, when that's done installing, what we want to do is we want to import from the .env, and we want to import the config function. Then somewhere in our app, I'll do it before we create our app over here, I'm going to call this config function. Now we have to create the part of our project that is going to configure the connection to our database. So I'm going to create here a folder called config, and inside of it, I'll create a file called db.js. Now, in this DB file, what we want to import is the Prisma client package. Now, we're going to create an instance of this Prisma client. Now, if you're not familiar yet with Prisma, the Prisma client library is going to help us have auto completion and type definition for all of our tables. So when we define here in our tables, when we create each table, they're going to have columns and types for each of those columns. And it would be nice to have auto completion and recognition of what those columns and tables are inside of our project. And you'll see that because of Prisma client, we're going to have that perfectly. Now, what I want to do is I want to create that instance by saying const Prisma is equal to new Prisma client. And in here, we're going to define just one thing, which is we want to add a simple configuration to this Prisma client, which is going to help us not break our entire project if there's an issue with our database. So with this log property over here, you can specify what kind of logs you want to see. And depending on your environment, if it's either development or production, you want to allow you to see different kinds of logs. So what do I mean by that? Well, I'm going to come here to our .env and I'm going to create a new variable. The variable I want to make is the node_env. And I always recommend you having that. Now, what is the node env? It stands for node environment, and you're going to set this to be either development or production. Now, because we are in development, I'm going to set this to development, but when we deploy this, we would change this to production. Now, why do we need to know this? Well, we need to know this because in a lot of different parts of our app, depending on whether or not we are in development or production, we're going to do things differently. For example, with this log configuration here, we're going to tell our database that if we are in development, which we can access an environment variable by saying process.env and then the name of the variable, so it's node_env. If that's equal to development, then I want to see the query issues, any errors, and any warnings. Now, if this is in production, I want to see the errors. Now, if you're not that familiar with this, don't worry. Just put this here. It will help you overall get better logs using Prisma. Now, the next thing we want to do in this file is create a function that is going to connect our database and a function that is going to disconnect our database. So I'm going to create here disconnect. Now, both of these functions are going to be async because connecting to a database is an asynchronous operation. Now, to connect to our external database, what we do is we apply a try and catch. And in our try, we await and we call Prisma.connect, just like this. Now, I'm going to put a money sign over here as well because that's what we need. And after connecting, we're going to console.log a message saying DB connected via Prisma. Then I'm going to copy this in case there's an error. And if there's an error connecting to our database, I'm going to console.error and I'm going to say that there was a database connection error, and I'll point out what that error is. So error.message. Perfect. And because we are running this locally, I want to exit. And when you say process.exit1, what happens is it will immediately stop our Node.js app and tell our system that it ended because of an error. Perfect. Now we're done with our connect DB and we can build the disconnect. The disconnect is a bit easier. We're going to copy this over here and just paste it here. And all we want to do is just call the disconnect function. And then at the bottom here, I'm going to export three things. I want to export the Prisma client that we created. We want to export the connectDB function and the disconnectDB function. Now, we can come to our server.js, and at the top over here, we're going to import the connectDB from /config/db.js. We're also going to import the disconnectDB, and one of the first things we're going to do together with the config here is we're going to connect the DB. Perfect. Now, whenever you connect to a database like the way we did over here, you need to gracefully handle cases in which there were issues, because we are connecting to the database, but when the app breaks, we want to disconnect from the database so that there is no memory leaks. So to do that, we want to handle three different situations in our computer's process that could lead to us wanting to disconnect our database. Now, there are three situations in which I recommend you doing this, and I always copy and paste it for my own projects. I do it the same for all of them. So if you want, you can just copy and paste this over here as well, and I'll go over what the three of them are. So there's three different situations in which we want to handle disconnecting our database. If there is an unhandled rejection, now this is an event that can happen in our process, and what we're doing here is we're listening to this event. Now in a NodeJS server, when you're running it and you do a process.on and you pass the name of a specific event, such as the unhandled rejection, it's going to listen to this happening, and when it happens, it does something. Now, what are the events that we have over here? Well, the first one is unhandled rejection, and this will catch any unhandled promise errors that we have in our app. So if this happens for any reason, for example, when there's an issue connecting to our database, it will actually be caught and it will run this function where we're going to console log the error and we're going to end our server. We're going to literally exit our server and at the same time disconnect from our database so there's no issues. Same thing with uncaught exceptions. If there's any uncaught exceptions, we'll do that. And if there is any issues with SIGTERM, which is a signal that is when your app is stopped in production, it will gracefully shut down our service and the database before exiting normally. Now, I don't think you need, if you're a beginner and you've never seen this before, I don't think you need to be obsessing over this at all. I would recommend just having this because this is the first step you're going to have to properly handling errors and issues in your server. If you don't have stuff like this, you might be open to possibilities and situations in which can break your API. So this is all we want to do. And now we're kind of ready to start building our database tables. Now, how do we do that? Well, to create a table, like I said, you could do it manually by coming here and clicking the create table. But most likely, I recommend that you have a structured type definition for each column that you're going to have for each table. And you should be using a unified language to do that. Now, if you're using Prisma, Prisma is the language for that. There is a .prisma file that comes with installing Prisma that is a schema. And in here, you can define the structure of your tables. If you're using something else, for example, MongoDB with Mongoose, you would have the same kind of behavior. Now, with this schema.prisma, what we're going to do is we're going to define the different tables we're going to have. Now, we'll define all of them at once, and it's going to help us have an idea of what kind of data we're going to be playing with in this project. The first one is, let's think about what this API is going to have. It's going to allow there to be users, right, who can add movies to a watch list. So right off the bat, I can think about a table for a user, then a table for movie, right, because a user adds movies, and then a table for each user's watch list. And I can think of those three interacting with each other in different ways. So we'll start off with the user model. So to create a table, you define a model. You give it a name, such as user, and you create an object out of it. Then inside of here, you need to define the fields of this table. Now, a user is going to have, by default, and by the way, every other table is going to have this, an ID. Now, an ID is going to have a type of string. And in Prisma, to define the type, you give it just like this. But with an ID, it has a very specific extra thing that you need to do. You define that it is an ID by adding this decorator over here called @ID. And you give it a default value by utilizing a UUID function. Now, it might be a bit confusing, but all we're doing here is we're defining the user table. We're saying that it has one column called ID. It is a string, and we're letting Prisma know that this is the ID of this table, and to whenever a new user is created, to generate a UUID for this user. UUID is just a standard of IDs that is used in APIs and in different database tables. It is going to generate a random ID for this user, and it's most likely going to be completely unique for each user. Now, the next thing that we want to do for a user is they're going to have a name, right? When you create a user has a name, and a username has a type of string. Now, the next thing is they're going to have an email. An email is also going to be a string, but we can add more properties to each column. For example, name is just a string. An email is a string as well, but we shouldn't allow there to be two users with the same email. So I'm going to add the unique property here that is going to apply to the user model. Then we're going to add a password field, and a password is also going to be a string. Now, the next thing is we want to keep track of whenever each user was created. So I'm going to add a created at field. And this is one of the other fields similar to ID, where you're going to have it on every single table that you create. And it's going to have a very specific definition other than just like string. Now, a created at is of type date time. It will always default to now, so that when you add a new user, it will automatically save the created at field to be the current time. And this should be good to go. Perfect. Now we have successfully created the model user. Now, what do I do with this? Because I defined this over here, but it doesn't exist in our Neon tables, right? If I refresh this, I don't see this in the database that we have being hosted in the cloud. Now, in order to actually send the changes that we make to this schema and have it be permanent in our table, we have to run the following command. I'm gonna run npx prisma migrate, which migrate is used for sending the changes that you have locally into your hosted database. Then we're going to say that this is not in production, this is in development, so I'll say dev, and then you have to give a name. Now I'm adding the users table, so I'm gonna give a name to this migration. I'm gonna call it add users table. And now if I press enter, it should send, but we get an error. It says that the environment variable it's missing. So what I think might have happened is we forgot to go to our prisma.config, and yeah, that's definitely it. We forgot to import over here the .env package. So if we import .env over here /config, then we should be good to go. Now there's actually one more thing I want to do very quickly, and it is you see this generator over here. This is just defining how we're going to generate the types for our Prisma table. Now, it's not that important for you if you're not really into, if you don't really care about the really deep details of this. What I would recommend is deleting this output so you don't have to have a folder with all your types on your project, and also changing this provider to be the JS one, just like this. Now, what we can do is we can run the command again, and it should be able to send all of our changes to our hosted DB. If there's any issues, we'll deal with it. As you can see, it says it was successful. We applied the migration add users table, but there's only one way to actually check it. We'll go back here and we're going to refresh this. And if everything worked, we should be able to see two tables, one for user, which is the one we just created with all of the columns that we defined, and one for Prisma migrations. This one is generated automatically, is every time we make any changes to our database, it is going to save with the name and when that happened. Perfect. So now we can come back here, and we need to do one more thing. Since we're using Prisma client, we need to generate the types for this table so that I can easily, for example, whenever I want to add data to our database, I could come to this route over here and say something like this. Users dot create, and then add the user. Now, this is obviously not how we're going to do it, but it's so that we have that type inscribed in us. So what we need to do is we need to generate our types after we made those changes. So on top of making this migration every time we make a change in our tables, we also need to run npx prisma generate, and it's going to generate the types for us. Now, as you can see, it generated everything, and we should be good to go. Now, again, we don't have anything yet visible for us to play around with. I want to create all the other tables before we start using them. Now, since I just went over how to create this first table, for the other ones, I'm just going to copy and paste the definition for them and go over what each field is so that we don't waste time writing each one individually. So the next table we want to make is the movie table. And for a movie, it's going to have an ID, just like the user had one. It's going to have a title, which is a string, an overview of the movie, which is also a string, but we can add this question mark to make it optional because sometimes there's no overview. Maybe you don't want to pass an overview. I put this just as an example for you guys to see how optional fields work like. Then we have the year in which the movie was released, which is an integer, any genres that match this specific movie, which is an array of strings. And you don't need to pass an array if there's no genres. It will always default to an empty array. We'll also have runtime, which is just how long the movie is, and it's an integer that is optional. A URL for the poster of the movie. We're not doing anything client-side related, so you guys won't see this. We're gonna add some fake data to mock this API, but you can put a URL to the poster, and then who made this movie, and also when it was created. So those are the fields that we want for the movie table. We can make the migration now so that we can see it appearing over here, but I'm also going to add the other table as well. Now the next table is going to be the watchlist table. Now we're going to call it watchlist item because it's an item, like a part of the watch list that each user might have, and it has the following fields. It's going to have an ID, a user ID, which is the ID of the user who is adding this movie to the watch list, then a movie ID, which is the ID of the movie that is being added, then a status, meaning have you watched this movie, or you're planning to watch this movie or not. Now this status has a specific type. It's called watchlist status, and it's not string, it's not int, it's not datetime, it's a custom type that we can define. To define a custom type like this one, this is an enum, which means you can either have you're planning on watching this movie, you have watched it, you're watching it right now, or you're not going to watch it. So to define that enum, you can do something like this. You define an enum, give it a name, and give the options. So there's planned, watching, completed, and dropped. And that's what the status is. And you can make it be, you can insert custom enums into the types of columns in your table. And you can also default it to something. So every movie I add to the watch list is going to be defaulted to planned, which means I'm planning on watching it. Then there's a rating, meaning you can give a rating, any notes you gave to the movie you added, and when this added item was created or updated. Now we're almost done, but there's just one minor thing I want to change. Each of these tables have specific relations to each other. And this is not a course on relational databases or databases in itself. It's just a part of building an API. So I won't go too much in depth onto it, especially because I know a lot of you guys might already be familiar with this. But we can establish relationships between each individual table. For example, a user creates a movie. So a movie has to have some reference to the user who created it. Same thing with a watch list. A watch list was created by a user, but it also contains movies. So there is a reference in the watch list table to a user and to a movie. And we already see those references appearing here. For example, a watch list item has a user ID and a movie ID, which is a reference to a movie and a user. On top of that, a movie has a created by, which right now looks a bit just like a string, but a user can create a movie, right? So this is also the ID of the user who created this movie. Now, to establish that relationship, we have the ID fields, but we need to do one more thing. For example, let's start with the watchlist item because it's the easiest relationship to understand, right? A user adds a movie to a watch list. So a watch list has a relation to a user and a movie. In here, we can establish the relations. Now, the first relation is to the user table. So we'll create a user field with a type of user. And we use the relation function here to establish that we're going to connect the watchlist item table by utilizing one of its fields with one of the fields in the user table. The fields we're going to connect is the user ID field in the watchlist item table with the ID field in the user table, because that's what it is, right? The ID of a user is the user ID in the user ID table in the watchlist item table. So we established that in the watchlist item table, the field user ID references the field ID from the user table. So this field is referring to this one. And one of the cool things we can do is also determine what happens when, for example, a user is deleted. So when a user is deleted and there is a watchlist item with a user ID equal to the ID of the user that got deleted from our table, then maybe this watchlist item should also be deleted so that we don't have lingering data when people delete their accounts. To do that, you can add an onDelete property called cascade, and cascade will do that. If you think of what the meaning of the word cascade means, it will have a cascade-like behavior where if one of the items in one of the tables is deleted, all of the items that have a relation to that item will be deleted on other tables. Now, we're going to do the exact same thing for the movies. So I'll create here a movie. It's going to be of type movie, and it's going to be a movie field. Now it relates to the movie ID field in this table, and it relates to the ID field in the movie table. Same thing. Now we're going to do the same thing for both the movie and the user tables, but they're a bit different. For example, in the movie table, we want to add a relation for the user, because this created by field over here refers to the movie creator. So I'm going to create a field here called creator, and I'll just make this not have this much space. And what this relation establishes here is it does the same thing we did before, where it gets the created by field in the movie table and it refers to the ID field in the user table, because this created by will be the ID of the user that created this movie. But it also adds this name over here. This is just a name for us to identify it, and we're going to use this name over here in the user table as well. Now the next thing is we're going to create a reference to the watch list. So a watch list item is a table that contains a user ID and a movie ID, meaning that there are movies that users add to a watch list. And that means that in a movie, there is a list of watch list items that refer to this movie. So there's going to be multiple watch lists that have this specific movie as part of it. So we can access all of the watch list items, all of the watch lists for a specific movie by accessing this field. Now we can do the exact same thing here on user. We can create the relations for user, and the relations for user are similar to the other ones. A user will have movies that they created. That's how we establish this relation. And it will have watch lists that it added movies to. Now, I understand if you're a bit confused right now, because this is a lot of database talk and we are getting to work on the APIs. If you are using a different database for this, to learn this, or you don't really care about databases, you just want to focus on the ins and outs of building an API, then I don't think it matters if you fully understand what we've done so far. This is all Prisma and PostgreSQL stuff. So if you want, I have a full course on Prisma in my channel, where I go into a lot more detail than what I'm doing over here. But the bottom line here is that we created our tables. And what we want to do is we want to run those two commands that we already ran. The first one is to migrate, but now we're going to change the name to added other tables. And you see there's an issue. First of all, it says watchlist items is neither a built-in type nor refers to another model. So it looks like we made a mistake here. And we did. We called watchlist items instead of watchlist item. Now let's try again. Same command. And if everything works right, we should be able to see our changes appearing. Perfect. Now we should migrate, or we should generate. So I'm going to run the generate command again, and we should be good to go. Now let's go check to see if all the changes are done. If I go over here and refresh, we should see the user, movie, and watch list item tables appearing in our project. So we're pretty much done with most of the stuff related to setting up the databases. Now we can get started on actually building our fully implemented API endpoints. Okay, so the first group of endpoints that I want to create is what I always recommend you to start with when you're building your API. And of course, I'm talking about authentication. Now, authentication is a huge topic, and we're going to go over everything that I think is reasonable for you to understand how to build a strong and secure API. And to do that, we're going to create another routes file in our routes folder, and it's going to be for the authentication. So we're going to create here an auth routes file. We're going to copy what we have here and we're just going to paste it here, but we're going to delete all of these routes that we created just as an example, because we're going to kind of start it from scratch. So one of the things that I want to already engrave in your minds right from the beginning is following a clean pattern for your APIs. And one of the patterns that we're going to be following here is creating controllers for all of your routes. Now, what is a controller? A controller is a function that is gonna have the actual handling of what happens in that API route when that API route is hit. So we could just write, for example, over here, a function for each route. But the recommended way in which you organize your project is that instead you create here a folder called controllers, and for each route that you have, you're creating a file over here that is going to be called, it's going to refer to that, so auth controller.js. Now for each individual endpoint that you have in this route file over here, you're going to create a corresponding function which is going to exist in this controller file. For example, the first endpoint that I want to create in the auth routes is the register endpoint. Now, to register a user, you're adding a user to the database table. So it makes sense that you would use a post request for that. Now, we're going to have here a post request with whatever name we want to use, but registering is very specific. So I'm going to use the name register, or you could use, for example, sign up or whatever you want. I'm going to use register. It represents your creating a user in the table. Then we want to call the register controller function. Now, that means that inside of your routes file, all that you're going to have here is the definitions of each routes, including what the HTTP method is and what the route path name is. But the actual logic is going to go on this register function that we're going to create on the controller file referring to this specific route. So in here, we're going to create a const called register. We're going to set it equal to an async function that is going to have a rec and res just like it had over here. Then at the bottom of this auth controller, we're going to export all of the controller functions that we're going to create in here. Right now we just have the register, so we'll just export that. And in our auth routes, we're going to import that. So we'll import from we're going to go back twice, go to the controllers /authcontroller.js and import the register function, and then this should work. Now, how do we register a user? There's a lot that goes into this. First, let's think about what happens when a user makes a post request to the register endpoint. Well, in that situation, which we can already start creating it over here, we'll create in Requestly a new request, HTTP request over here, and we're going to call it register user. Now, we're going to make this into a post request, and we're going to insert the base URL. We're going to go to the auth route, and we're going to go into the register endpoint. Now, because we are going to the auth route, because we created a new route in our project, we have to do that thing that we did with the movie routes, which is in our server.js, we're going to import the auth route over here. So import auth routes from the auth routes file, and we're going to use it over here and pass auth as the endpoint path. Then we have to pass the auth routes, and it should be good to go. Now, the way we have set it up right now, right, where we have this post request to the register and it calls this function, we could test it out like we did before and return back a message saying that it works. I don't know. We can test this out. Let's go to Requestly. We'll make a post request to this route and we're going to send it. You see, we get back this. So we configured everything correctly, but now here's what happens. When you make a post request, usually you're trying to create data in your table. So you're trying to add data to your server that comes from the client. The way you send data from the client to your server is through this request variable over here. Now, inside of this request, when I say request, it actually allows us to access a bunch of things about the request, such as the headers, the parameters, anything else. But there's this thing else over here that is very important called the body. And the body of a request is kind of like a JSON that can be sent from the front end to the back end, containing data that you want to use in the back end. So when we're trying to register a user in the front end will have a form where they can type in their name, their email, and their password. They're going to make an API request to this endpoint, and they're going to send through the body of the request the data for the name, the email, and the password. So here we're going to assume that that's going to happen. We're going to get back the body from the request. So we assume that when they make this API request, they're going to send that data through the body, and that this body will be an object containing a name, an email, and a password. Now, how do we make sure of that? Well, here's what I'm going to do. I'm just going to return as a response the body, so we can test this out. If I make this request right now, it's not going to return anything. Why? Because we never passed a body on Requestly. Now, to pass a body on Requestly is very simple. You go here to the body section on this on the request that you created, and it allows you to either pass a text, a JSON, this format over here, or multi-part form data. Now you can choose whatever you want. I'm going to pass it as JSON just because I think it's easier for you guys to understand. So what I want to do is I'll define here a JSON in this request. Now we want to send three things: the name, the email, and the password. So when we register this user, we're going to send, let's pretend we're registering a user with the name Pedro, with an email equal to example@gmail.com, and with a password equal to, password 123. If I send this and everything is working and we are getting this body that we're sending in the request, we should just get it back over here, but we're not. And the reason for why we're not is because Node.js and Express servers don't know how to naturally handle JSON by default. We actually have to make one change to every single API that we create that is going to set it up to accept that. Now, what am I talking about? Well, we want to allow the parsing of what comes in through the body to be properly handled. Above our API routes over here in our server.js, I'm going to add a section for the body parsing middlewares. Again, we haven't dealt with middlewares yet, but what we're doing here when we say use, we're applying a middleware. And what we're going to apply here is this middleware that comes with Express, called express.json, that is going to make it such that with every single request that we have, when some JSON format is sent through the body, it's going to properly handle it. Now, the second one that we want to send is the express URL encoded extended equal to true. This is not fully required. It basically says that to Express to automatically parse data from an HTML form submission so that you can access it in the request.body. Now, we're not necessarily going to have a front end here, so we're not going to care that much about this, but you just apply both of these and we should be good to go. Now, if you go to Requestly and we click send, we should be able to see that it properly handled the JSON that we sent and it just returned it back to us. Now let's go back over here and let's continue building our register functionality. So the next thing we want to do is we're going to finally start dealing with our database tables. So I'm going to destructure or get the name, the email, and the password from the body. So I'll do this. Now this is the exact same thing as doing, for example, this over here. We're just getting the name, email, and password instead of creating a variable called body. So we'll just do this. Then what I want to do every time when you register a user, we start with the following process. We're going to check to see if user already exists. To do that, I'll create here a user exists variable. I'm going to await because it's an asynchronous operation, and I am going to access the user table in our Prisma database and trying to find if the user with the email that is being used to register this user already exists. Why? Because remember when we were defining what a user is, we said that you can't have two users with the same email. So what we're doing here is if a user tries to sign up to an account and they use an email that already exists on the table, we're going to know because this user exists variable is going to be filled in as true. So this is the first time we're making a request to our table. How do we do that? Well, first we need to access Prisma, but not Prisma from Prisma client. We're going to access the Prisma from our db.js file over here. So we're going to import at the top, import from config/db.js, and we're going to import the Prisma client instance. Then you see that because we ran those commands Prisma generate, when I do Prisma dot, it automatically has a field for movie, user, and watchlist item, which is crazy because we defined them and it has that autocomplete for us. So we're going to access the user table with Prisma and we're going to call one of the many functions that they have to make operations on that table. The operation we want to make is we want to look for a unique item in this table that satisfies a certain condition. So I'll use the find unique function, and the find unique function allows us to check to see if there is a unique user where their email is equal to the email that is sent in the request. Now, if that happens, then we know that the user is trying to sign up with an email of another user that already exists. And if that happens, we want to actually handle that error. So I'm going to come here and I'm going to say if user exists is equal to true, then I want to return a response user.json that is going to be an error. Now, how do we define an error? Now, this is an error. So when we return this response, we don't want it to be a response that is returned with a 200 status code. Now, if you're not familiar with status codes, I recommend just searching up on Google over here. There's some cool images. I just zoomed in into one of them over here. There are obviously way too many status codes that you can have on an API, and you don't need to memorize all of them, but there's a couple ones that are definitely important. Whenever there is a success, for example, your API request was successful, it's probably going to return a 200 status code. So there are a couple different specific versions of that 200. The most common is just 200, but there's 201, 202, and so on. And if there's an error in your client, then it's probably going to return a 400. If there's an internal error in your server, it's going to be a 500. Now, it's important for you to understand the distinction between 400s and 500s, but the rest, like 100s and 300s, it's pretty much okay for you to not know. Now, in order to specify the status code when you're returning something, you can just add a .status before you return the JSON. This is a function, and you can pass in a specific number, like for example 400 for this request, and it will return as that specific status code. Now in the JSON here, we want to return an error message that says user already exists with this email, and we're returning because then it won't continue moving forward with the request. Now we can't really test this right now because we don't have any users in our table, but we'll continue moving forward, and we're going to test this when we're done. The next thing we want to do is we want to hash the password that the user has sent. So I'm going to put here hash password, and what this means is we're going to want to not store the user data in our database. Like for example, if the user passes a password, we don't want to put the plain text like this. Why? Because this is completely insecure. What you need to do is you need to hash it so that when it's stored in our table, not even us as the managers of our table, we can see other people's passwords. Now, to do this, the easiest way to do it is by utilizing this package called BigCrypt.js. So I would need you to install BigCrypt.js, and at the top over here, we're going to import BigCrypt from BigCrypt.js. And hashing is actually pretty simple, and it's always going to be the same thing. You do it always. You need to get this variable called salt. It's basically a representation of how hashed you want your password to be. But we're going to await BigCrypt and then call the gen salt function. And I'm going to use 10 as the amount of routes. Then to actually hash the password, you're going to create this variable called hashed password, set it equal to await, and you're going to call the bcrypt.hash function. Now the bcrypt.hash function takes in a plain text password like this one and a salt value, which is what we generated over here. So we're going to pass here the password and the salt, and we'll have a hashed version of the user's passwords. Now that we have that, we can add the user to our table. So I'm going to create the user by adding create user over here. And to create a user or add an item to a table in Prisma, we can just call the await prisma.user.create function. And then inside of here, we can pass the data through the data key. Now, a user, if you look at how we defined a user in our schema, it has a couple things, but the only things that we ourselves have to send when we're trying to create a user is a name, an email, and a password. So in here, I'm going to pass the name, which we get from the body of the request. Then we're going to send the email, which we also get from the body of the request. And finally, the password. But the password, we're not just going to send the plain password. We're going to send the hashed version of that password. Now, when this is done, we should be able to create a user. I'm going to test this out really quick before we deal with login, because that's a whole different thing. But what we can do here is when it successfully creates a user, we can return a response with a status. And because we're creating something, we can use the status 201. Now we're going to return a JSON that has a very specific format. When I am doing something like, for example, creating a user, I like to be very specific with how the return of this API endpoint exists. So I'm going to pass a status of success. Then I'm going to pass some data, and the data is going to include the user with the ID of the user that was created, which by the way, we can get because when Prisma creates the user, it returns it back to you in this variable. So I can now get the user ID, then I can get the name, which is just the name that we get back from the body, and also the email that we also can just get from the body of the request. Now we can test this out. You see, in our neon.console on the user table, there's absolutely nothing in here. But if we go to Requestly and we were to create this user, now if we try to register the user, we should see that it was 201, so meaning we successfully did it, the status is success, and we get this information about the user. Now if I go here to our database and I refresh it, we should see that one user was created on our table, meaning that we successfully created the register endpoint. Also, if you notice, the password that appears here is this weird huge string because this is the hashed password. When we deal with the login, we're gonna deal with getting that and detecting if it's correct, right? Because you can't unhash a password, because then what would be the point of hashing it? Because then you could just unhash it and then you would see the plain password again. But what you can do is in the login functionality, you'll see that if we hash the same string twice, it's going to give the same value. So that's a good way for us to detect if a user can log in or not. So let's actually do that. We'll get started with building the login functionality, which is super important as well. For login, we are going to be working with JWTs, which is JSON Web Tokens. It's a way for us to verify credentials, and JWTs are small signed tokens that will allow the server to verify if a user is who they are, without having to actually store the information about the session on the backend. So it's extremely useful for stuff like authorization and authentication, and it's how we're going to set up the backend infrastructure for authenticating users in our project. So to start with the login functionality, I'm going to create here a login function, and it's going to be similar to the function that we have for register. It's going to be async. It's going to have a rec and a res. And we're going to also, whenever we're logging in a user, we're going to send some data through the body. Now, if I copy this, I'll paste it over here. Differently from registering, we don't want them to send their name. Logging in just requires people to send their email and password. And the first thing we want to do is find to see if there's even a user with that email that they're trying to log in. To do that, it's exactly the same logic we wrote here for checking if the user exists. But instead, we're going to say check if user email exists in the table. So we're just checking to see if there's a user with a unique email equal to the email the user is trying to log in. Why? Because if the user doesn't exist, right, we're gonna have to return an error because you're trying to log in with an email of a user that isn't in our table. So we're gonna check if user doesn't exist. So if no user, because if Prisma doesn't find a unique user with this email, this is going to be null. So if no user, then return a 401 with a JSON saying invalid, we'll put here invalid email or password. That means that, for example, right now, if I were to come to Requestly and I were to create a new request, it's going to be a post request. We're going to change this to say login user, and we're going to put this as part of this workspace. Then we're going to put the base URL, then /auth/login. That means that we also have to create the routes over here. So let's do that. Let's create here the post request for login, and we'll put here the login function. We just have to import it here as well, and then export it at the bottom here. Then what we can do is on Requestly, we can send a body. I'm going to try to send a JSON for signing up with a user whose email is equal to an email that doesn't exist in our table, right? We only have one user in our table, so that's going to be easy. And for the password, I'm actually going to put the correct password so that we can test it later on. But if I send this, what should happen now is we should get back this message over here, invalid email or password. And as you can see, this is exactly what happens. But if I were to put the correct one, which I think is example, I think that's the one I used to sign up, we should not see anything. And we don't see anything because we never did anything other than this. We never sent another response after this. But that's what we're going to do now. After detecting to see if the user actually exists, we want to verify the password. Now, to verify the password, it's actually pretty interesting. We're going to create a variable here called isPasswordValid. If so, we're going to await and call bcrypt, and we're going to use the compare function, because the compare function is going to compare a plain text password that the user put on that they sent on the request, and the hashed password that we know exists in the user's table. Now, because we were able to find the user with that email, we can get the password that is hashed on the table by saying user.password. And then when we get that, we will be able to do another check to see if the password is valid. If the password is not valid, then we want to return the same kind of error. We don't want to let them know that just the password is wrong or just the email is wrong. We want to send back like a very generic error, because then they don't have more insights of what the password or the email combination is. So you see that now, if I were to send the correct email, but something wrong for the password, we get the same error. If I were to send the correct password and the correct email, we get no error back. Perfect. Now, after this is done, we're just going to copy this exact same return that we had for the register, and we're going to return this. Now, when we're talking about JWTs and the beginning of this, we haven't done anything related to that. You see, if I can, one thing we want to change is we don't want to send back the name, because that's only for registering. You see, we successfully log in and everything is fine, but do we actually successfully log in the user? Not really, because one of the parts of logging in is generating a token that is going to represent that instance of the user logged in. That token is the JWT token. And then that token is then going to be used in every single request we're going to make for the rest of this API in order to always verify that this user is the user that they are talking about, like that they are the actual correct user. Now, right now, it might not be fully understandable what JWT tokens are. When we get to middlewares, which I believe is the next topic, you will understand. Now, to generate a token, we have to do it both on the register and on the login. So right after we verify that the password is valid, I want to generate the JWT token. Now, to do that, we're going to have to install the JSON Web Token package. So I'm going to come over here. I'm going to say npm install JSON Web Token. It's going to install it. And we're going to create a helper function that we're going to be using whenever we want to generate a JWT. Now, we don't have any place to create that helper function. So I'm going to create a folder here called utils. And utils is basically any kind of helper file that contains a function that we might want to reuse throughout our API. And here I'll create the generate token helper file. Now for the generate token, I'm going to import JWT from JSON Web Token. And then I'm going to create the generate token function. Now this generate token function will create the JWT token, and we're going to store a part of the user in that token. And that part of the user is what we're going to be using to identify that the user is who they're saying there is. And that part is the user's ID. Then it's going to sign this JWT with our own personal server's secret key. And that secret key will make sure that other people can't just fake a JWT from their part. Then whenever we make an API request, we're going to pass that token to verify between every single request. Now to create that token and sign it with our secret, we have to do the following. First, this function will require the user ID. So when we generate this token, we're going to pass the user IDs. And then inside of here, we're going to create a variable called the payload. And this is the payload that is going to be inserted inside of the token. Now in here, we're going to insert an ID with the user ID as being its value. This is what the token is going to be like. It's going to be an object. Now we're going to transform it into like a string of letters and numbers, but when you convert it back, it's going to be an object. Now to create that concatenation of letters and numbers, we'll create the token, and we're going to use the JWT package to sign the payload. Now to sign that payload, we need to use our own special secret, like I said. Now that secret, we're not going to put it directly here. We're going to create an environment variable for it. We're going to call it JWT secret, and we're going to set it equal to something. Now, I don't recommend you writing your secret yourself. I recommend you generating a random one and using it. To generate this secret, you can actually use this very nifty command, which generates a base64 random secret that you can use, right? So you run the command, you copy this, and you paste it here. Then we also want to determine how long we want the token to be valid. So like when a user is signed in, we want to determine until when they are signed in a way. So we're going to create here a JWT expires in, and we're going to set a value to it. Now you can set whatever you want. I'm going to set 7 days, just like this. And this is how the format of what you need to pass. It has to be like 7 and the number and then the format. If you want to put like, for example, minutes, you do this, seconds, you do this, and so on. But I'm going to use 7 days. Then in this function, I'm going to pass first the secret by getting the .env.jwt underscore secret. Then I want to insert the expires in and pass the process.env.jwt underscore expires in value. Now, if for some reason you don't pass an expires in, we can also just default this to 7 days because I think it's the default, and that should be fine. Now, when this is done, we can just return the token. And in our auth controller, where we want to generate the token, we can call that function and get the token back. So we're going to call the generate token function, which we need to import over here at the top. So I'm going to say, did we import that function at all? I don't think we did. That's why it didn't go automatically. Yeah, what we can do is we can just export this function just like this. And then in here, when we call the generate token function, it should have imported automatically, but we can just do it over here as well. So import from, go back twice, go to utils, then generate token, and import the generate token function. And then we pass the user.id to this function, and it should generate a token for us. Now, what do we do with this token? Well, we are going to pass it over here as part of the data. And we want to do the same thing when the user signs up. So when they register, I'm going to copy this, I'm going to put it over here, and I'm also going to pass the token over here. Now, what does this mean? It means that now when I try logging in, it's going to have a token, right? And you see, this is the token that shows up, but what is the point of this? Well, when you are in the front end, like every time a user signs up in the front end, the token will be generated and we're going to get it back in the client. And in the client, they're going to store that in their cookie or wherever they want to do it. They have to store it in a secure place. And that's why I don't recommend them storing it on like the session storage or local storage. They have to store it on the cookie and then use that value for every single other API request that they make. And then every API request will be validated based on this token. That's how you protect your API endpoints. Now, the next thing that we need to do is actually set the token that we generated inside of the user's browser. Now, like I said, when we get back this token, you might get the token and put it wherever you want in the user's browser. You can put it in the local storage and so on, but those places are insecure and it's recommended that you set it to their cookies. However, there's different types of ways in which you can set a token on a user's cookies. One of the ways is insecure and the other way is secure. The way that we want to do it is through what is known as HTTP only, so that JavaScript that is written on the user's browser can't access the token. Now, the way we do this is by actually passing the response that we have here in the controllers to the generate token function. Now, what is that going to help us with? By getting the response over here, we are able to set the cookie by setting a cookie on the response, giving it a name. We can call it whatever we want. I'm going to call it JWT. And then we can set the value of it. Now, the value of that cookie is going to be the token that we generated. When we return a cookie in the response, it's like we're setting the cookie for the user because it's part of the response. Now, the next thing we want to do is specify some other things about this cookie or this cookie that we're creating. For example, we need to make sure to set it to be HTTP only. So we're going to say HTTP only is equal to true, because again, that will make it such that the user's browser can't use JavaScript to access, or other people's JavaScript can't access it. The next thing is we want to set it to be either secure or not. Now, secure will allow us to set a true or false statement, and we only want to do it if the user is in production. So we're going to access our node env variable and check to see if that value is equal to production, which, as you remember, it is not. It's set to development. Then we're going to use a same site. If you set this to be strict, which is what we're going to set, it will stop the browser from sending this cookie on cross-site requests, which will then protect against CSRF attacks, which is one of the most common types of attacks that there is. Now, finally, we want to set the max age of the cookie. Now, if you remember, we set it to be 7 days for the token, but for the cookie, we have to set it in a different format. We can't just write 7 days. We actually have to pass it in milliseconds. And if you're not familiar with how milliseconds work, basically we get the value, right? For example, I have 1,000, and then I multiply it times 60 because that's 60 seconds, and then in 1 minute. And then I multiply it times 60 again, because then that's 60 minutes in 1 hour. Then I multiply it times 24, because then that's 24 hours in 1 day. And now all of this multiplied times whatever amount of days we want, which in this case is 7, we'll set it to be 7 days in milliseconds. Now we are successfully setting the cookie, and all we have to do is also pass the res on the login function over here, and it should work as well. Perfect. Now let's create the last function that we want, the last route that we want in the auth, which is also the ability to allow a user to log out. To do that, we are going to come here to the auth controller, and we're going to create a logout controller function. I'm already going to create it over here, just at least the skeleton, so we don't repeat ourselves. It's just going to be an async function that in the end, after you successfully log out, it's going to return a status 200, meaning it worked, and a JSON saying that it was success and that we logged out successfully. Now, what does it mean to log out in the sense, in the backend sense? Well, for the backend, logging out means removing the cookie with the JWT token from the user's browser. And you can do that by using the res.cookie function like we did before. And instead of setting it to be something else, we're going to update the JWT cookie that the user has and set it to nothing, just an empty string. And not only that, but we also can set the expires value to be the current time. To do that, we do new date 0, and it will be basically right now. So it will expire at the exact moment you call this. Also, I want to set it to be HTTP only equal to true. And it's as simple as that. This will log out the user. Now, to make this route, we're going to come here and we're going to create the logout. We're going to create another route over here, and this will also be logout. We're going to pass the logout function here, and they will auto import there, and then we should be good to go. Now let's test to see if this is working. We're going to open up Requestly. We're going to create here another HTTP request. This one is going to be logout user, and again, same things as before. We're changing this to post. We're putting the base URL, and then we're doing /auth/logout. Then we don't need to pass anything to it. We're going to click send, and let's see what happens. It says successful. Now, if we go to the headers here, you see that one of the things that we get from the headers of this request is that it sets a cookie with the JWT equal to this. Now, if we go to login and we try to log in again, and we go to the headers, you see that the set cookie set the cookie to be the exact token that is generated when you log in. So we are successfully doing that for both scenarios. We're setting the cookie here, and then when we log out, we remove that. Now, logging into an account, logging out to an account doesn't really make sense, I understand, if you're not seeing the front end happening. But it will make sense when we start creating our other endpoints, because all of our endpoints are only going to be successful if the user's logged in. So we're going to actually be able to see that happening by using Requestly. So let's start with that. Now, in order for us to continue, I want to actually add data into our tables, because in the movie table, there's no movie for us to add to our watch list. So I want to add a bunch of fake data over here. More specifically, I'm going to add 10 movies into here. And I'm going to show you guys how to do this with your APIs. You can easily add fake data by creating what is known as a seed file for your database. Now, to do this, what we want to do is the following. We're going to start by creating another user account. This will be, I'll call it Tarantino. It's the person who's going to be the creator of all of the movies. I don't want to use my same account to create the movies. I'll create a different person. Let's create Tarantino@gmail.com, and I'll use the same password. Now let's click send. It should create this user. We should be able to see it in our table. Now there's 2 users. And now I'm going to log in as Tarantino. Let me do here, Tarantino@gmail.com. Perfect. I'm logged in. Now, what I want to do is I want to add a bunch of movies, and all of those movies are going to have Tarantino's account as the created by. That's why we created this new account. Now, to do this, we're going to create the seed file for this operation. And a seed file is basically a file that contains a function that all it does is it adds some mock data that you can use to play around while you're building your website. Every single website I build, I create a seed file in my API so that when I'm building, I don't need to be constantly creating new data for me to test, right? You want to have a bunch of fake data that you can easily test with. And this is great because of that. Now, to create a seed file, we're going to go to our Prisma folder and we're going to create a seed.js. In here, we're going to import Prisma client from Prisma client. Then we're going to create that instance of Prisma. Now, the reason why we're creating a new instance of Prisma client instead of just using the one that we had from our config.db is because this file won't be part of our API. It's going to be a script that we can run whenever we want to seed our database, meaning whenever we want to add more stuff to our database. Then we're going to create here user ID or creator ID actually. Now the creator ID, we're going to put whatever we get back here from Tarantino. So this is Tarantino's user ID. Now I would recommend you to actually create an environment variable for this if you're going to be deploying this. But for now, I'll just put it directly over here. Then you want to make a list of mock data that you want to insert into your table. For me, I already have this because I obviously made this already, and I'll leave it together with the code in the description. But it's just a list of a bunch of movies that really exist with the correct information for each of them. And we're going to add this to our database table. Now, in this list, we have 10 movies. And what I want to do is I want to create here a function called main. It's going to be an async function, and it's what's going to create or add those into our table. Whenever I run this script, it's going to call the main function. So to have a visual representation that this is working, I'm going to console log the following message: seeding movies. Perfect. Then what I want to do is I want to loop through the list of movies. So for const movie of movies is just a normal for loop. I'm going to call the Prisma client, access the movie table, and create a new movie. Now for this movie, what I want to create is I want to pass the data, and the data is going to be the individual movie from each element in this array. Then while that's happening, I'm going to console log for each movie that it was successful. So I'll say created movie, and then I'll insert the title of the movie over here. Then after all of them are done, I'm going to console.log a message saying seeding completed. It's as simple as that. Finally, I'm going to call the main function in this script. And because it is an async function, we need to catch any errors that happen. So if there's an error, I want to catch it, and I'm going to console.error it so we can see what's happening. And also I want to close my server by exiting it by saying process.exit1. And then no matter if it was a success or a failure, we're going to run this finally clause where we're going to disconnect our table or our database. So we're going to say await prisma.disconnect. Perfect. And now we should be good to go. But how do we run this script? There's a couple ways. We could just do node and then put a path to this file. But one easy way for you to do this always is create a script on your package.json like we made for NodeMon. What I can do here is create a seed movies script that I know that whenever I run this script, it will add those movies to our table. And what this script does is it runs the node command and it accesses the prisma/seed file. So prisma/seed.js. Now, if we come over here and we run npm run seed movies, you'll see that it has an error. And that's because when I copied the data from what I written before, we're passing the user ID instead of creator ID. I'll just change this to user ID so that I don't have to redo it a bunch of times. So at least we know we're running the function correctly. So I'll come over here, I'll run this again, and you should see that it created all of the movies. Now, if I go here to our table and I go to the movie table, you see that Tarantino created all of the movies and they're all over here. Perfect. We're in a prime position for us to start building the next set of API endpoints. So which one is it? Which one do we want to create? Well, we want to allow users that have created an account and are logged in to add movies that exist into their watch list. Now, we already have this movie routes. We're not really going to touch on that. I'll create some in the end of the video and show you guys. But what we need to focus on is allowing the user to add movies to their watch list. So in here, what I want to do is create the watchlist routes.js. Now, it's going to be very similar to what we have here for the auth routes. So I'll copy this and I'll paste it here. Now, the main difference is obviously the routes are going to be a bit different and the controller is going to be a bit different. But with the route that we created, we can create here a controller for it. So I'll create the watchlist controller.js. Now let's start with the simplest route that we can create here. I'm going to comment this routes. Actually, I'll just change them. The simplest one that I can create is a simple post request to the watchlist routes that allows a user to add a movie to their watch list. Now, how do you do that? Well, we're making a post request that is an empty because it's just the only post request that is going to exist in these routes. So we don't really need to give any extra names. And we're going to call an add to watchlist controller. Now, this function is going to be created over here. We're going to create the add to watch list. It's going to be an async function. It's going to have a rec, a res, just like all of our other ones. And the first thing we need is when we're adding a movie to the watch list, we need to get from the request inside of the body a couple things. We need to know the ID of the movie that we're trying to add to the watch list, the status of that movie in the watch list. So if I'm planning on watching, if I already watched or that kind of stuff, the rating that I'm giving, if I am giving anything, and any notes that I have. Then what I want to do is I need to first verify that the movie that I'm adding exists in the movies table. So that's an important check to do first, so that we don't break anything. To do that, I'm going to say const movie is equal to await prisma.movie.find unique. Now, what is this doing right here? Why is it giving us an error? We have to import the Prisma client from our DB file. So I'll say import Prisma, and it's not really not appearing over here, but we'll say from, and then we'll import from the config/db. Now in this find unique, we're going to try to find a movie where the ID of the movie is equal to the movie ID that is being passed in the body. Then if there is no movie, we're going to return a res.status of 404. 404 is usually an error status code that represents not finding something. And I'm going to return a JSON that has an error saying movie not found. Now, after we confirm that the movie exists, we want to check to see if I already added it to the watch list. So I'm going to create here another check. I'm going to actually copy this. I'm going to put some comments here, check if already added. And what I want to do is I want to copy and paste this over here, but change this to say existing in watch list. It's just a Boolean that is going to let us, it's not a Boolean, it's going to come back with the actual data, but because we can check to see if it's null or not, we can make sure that the items are not already in the watch list. Now, how do we check? Well, think about it this way. What defines a watch list item? In our schema.prisma over here, a watch list item is, it has a specific ID, but we don't have access to that ID. What we have access to is the movie, right? We have access to the movie. And also, when we make this request, we're also going to have access to the user ID. So we could get now how are we going to get that information? We don't have it in the body. Well, for now, let's just assume we're going to pass this through the body, the user ID, and find a existing watch list that has a combination of the movie ID and the user ID that is the same. However, later on, we're going to, when we're working with middlewares, we're going to actually access this not from the body. Now, what we want to do is in the schema, a unique watch list item is a combination of a user and a movie. So what we can actually do in this Prisma schema, I didn't do this before because I wanted to get to the use case so you guys understand what we're doing, is I can define a unique relationship between those two fields. To do that, I can add two ampersands and say unique, and I can pass an array saying that no watchlist item will have the same combination of user ID and movie ID. Now, why does this matter? Because by establishing this, we're going to have access to something really cool. I'm just going to migrate this so that we can get this. I'm just going to say added constraint. That's the name. Migrating it, and let's see what else. Oh, it's asking us if we want to add something to a file, to a table that might have duplicates. I'm going to press enter, like yes, so that it does that. Then I'm going to clear this out, and we want to just generate the new types. Perfect. Now, what we have access to, because we did that, is in this where clause over here, we can access a combination of the user ID and movie ID, as you can see, which we didn't have before. And we pass the user ID as the first thing. We're going to pass the user ID from the body. And the second one is the movie ID that we also get from the body. Perfect. Now we are checking to see if it exists in the watch list. And if it does, we'll do the same check we did with the movie. Then there's going to be an issue. We're going to return an error saying movie already in the watch list. Now, a 404 doesn't really make sense in this case. A simple 400 should be good to go. Now we're ready to create the watch list item. Now, what do we want to do? Well, I want to create here a variable called watchlist item, set it equal to await prisma dot create, actually dot watchlist item table dot create, and we're going to pass here the data, which is an object that is going to require us to pass a user ID, which we have from the request, right, the body, then a movie ID, which we also have from the body, then we can pass a status. Now, a status, it depends on whether or not you have passed in the body. If you have, we're going to get it back. If not, we're going to default to just planned because you're planning to watch this movie. Then we're going to pass a rating and any notes. Perfect. In the end, if this was successful, we're going to return a res.status201 and say .json with a status of success. And then we're just going to pass any data, which is going to be the watch list item that we just created. Perfect. Now we have this function that we can export at the bottom and import it over here. Now to import it, I'm going to change this to say watchlist controller and then import the add to watchlist function. Now it's not done yet because we have to apply this new route, the watchlist route, by going to our server.js, importing it at the top here, changing it to watchlist routes, changing this to say watchlist routes, and then coming down here and applying it as well. So we're going to say /watchlist or whatever you want to call this, and then apply the watch list routes. Perfect. Now we should be good to go. We can finally create our first, add our first movie to our watch list. So I'm going to create an HTTP request. We're going to say add movie to watch list. That's the name. Then we're going to make a request to the base URL /watchlist, and we don't need to do anything else. Why? Because as long as this is a post request, because we made it such that the watch list route for adding is just a empty slash, because it's going to be the only post request we're going to have in this route, we don't need to do anything else. Now, what we do need to do is add a body to this request. So we're going to add a JSON over here, and we need to pass in a couple things. We need to pass in the movie ID, the user ID, the status, the rating, and the notes. So we'll create here an object, pass in a movie ID. Now, which movie ID should we add? Let's check our tables. Which movies should we add? I'm going to add Interstellar. So I'll copy that and I'll come to Requestly and I'll just paste it over here. Then the second one is going to be user ID. And the user ID I want is for myself. It's not Tarantino, it's Pedro. So I'll log in as Pedro. Let me just see it was successful. This is my account. I'm going to copy this ID and I'm going to come back here and just add it to the request. Then what do we need as well? We need a status. I'm going to leave the status as empty, or I can just pass planned, to be honest. I'll just say status planned. Then rating, I'm going to put as 5.0. I think is rating a number? Yeah. Then not 0.0. I'll just say a 9 out of 10. And I don't want to put any notes. I think this should be good to go. Let's go back over here. I think this should be fine. And let's make this request. It says movie already in the watch list. Now, why is that? Let's go back over here. Oh, this is a mistake from our part. We shouldn't do a not over here. We should check to see if the movie exists, not if it doesn't exist. If you caught that early, that's a good thing. we can just come back over here and send it again, and you see it was a success. So if I go to our table, our watch list table now should have one item. If I try adding it again, boom, doesn't work because it's already in the watch list. Now, did you see an issue with this? Because I certainly did. We added a movie to the watch list, but there's no guarantee that the user logged in is the user who passed this user ID. And this is a big issue when you're dealing with building an API that is secure. Now, the way you prevent this is you make sure that the person who's making this post request always have to include the JWT token that refers to the user with this specific user ID. And that's the biggest part related to authentication and authorization. Okay, so what exactly are middlewares and how do I create one? Well, a middleware in Express is a function that is going to sit in between a request and a response. And it will let you run the code in between those two, modifying the request, checking any permissions you might want to check, or even stopping the request before it reaches the route handler that we created. So basically, it's a function that whenever someone makes a post request to this route to add a movie to the watch list, it's a function that is going to run before the actual route handler function that we have here, the controller function. Now, what is the point of that function? Well, in that function, we can do a bunch of things. For example, if you have an API where certain API endpoints require you to be a specific role, like an admin in your API, to be able to make that API request, in the middleware is where you would check for the role of the user. In here, when we're dealing with authentication, we want to add a middleware that will check to see if the user has a JWT token when they are making a request and validate to see if that is the specific user that can make that request. Now, how do we do that? Well, I'm going to create a folder here in our source folder, and it's going to be called middleware. Now, inside of it, we're going to create our first middleware. It's going to be called the auth middleware.js. Now, in this middleware, we're going to import at the top the JWT package from JSON Web Token, and we're also going to import Prisma from our DB file. So we're going to go to config db.js. Then we're going to create our first middleware. Now, like I said, a middleware is just a function. So I'm going to create a function. We're going to give a name to this middleware. It's going to be protect because, or you can actually, I can just call this auth middleware because it makes more sense. And I'm going to make this an async function. Now, to run this function before every single request in, for example, the watch list routes, what I have to do is I have to apply this middleware. Now, to apply a middleware to a specific group of routes, all I have to do is say router.use and then apply the middleware function. In this case, it's going to be the auth middleware function that we can just export over here. Now, by doing this, we can import the auth middleware, and now whatever we put over here will run before any of this post requests. Any routes or any HTTP methods that we put over here will also run this function. Now, how do we test this? Well, I'm just going to console the log here saying auth middleware reached. And what I'm going to do is I'm going to go back to Requestly and I am going to I'm going to add a new movie to my watch list. And you guys are going to see that now on our console log over here, it's going to say that it reached the auth middleware. Now, to do that, we need to first come here to our table, go to another movie that isn't Interstellar. I'm going to get the ID of Pulp Fiction, and then we're going to go to Requestly, and we're going to add another movie to the watch list. Now, we're going to use the same user, but we're going to add the new movie. I'm going to change the rating just for simplicity, and I cleared out my terminal. Let's run this. So it says that it is sending a request and it's not actually finishing that request. So this is a bit different from what we had before. Now, the reason why this is happening is because if you go over here, you see that it did console log the auth middleware. And the reason why it's pending, it never actually finishes the request, is because when you apply a middleware to an API endpoint, you have to tell the middleware to continue on to the request. So here, we're going to have some checks like the ones we want to make to see if the user is authenticated. And if the user is authenticated, we can tell the middleware to continue on to whatever the endpoint route handler has in their function. Now, to do this, what we have to do is we want to, and I'll write over here as a comment, we want to read the token from the endpoint or the request. Then we're going to check if token is valid. Now, how do we do that? Well, every time you make a request to an endpoint that requires authentication, such as this one, we're going to require now that the person making the request, the client, sends in the JWT through the headers. Now, why not send it through the body? Well, because the request headers, which is this part over here of the request, is designed for authentication data, while the body is actually designed for the content of the request. So whenever you're doing anything like, for example, sending tokens for authentication, you want to keep it on the header because that's the standard and it makes it cleaner, more consistent, and so on. So what we want to have is whenever someone makes a request, we want them to include in the headers in a key value pair. Now, the standard is that when you send the JWTs, the key is sent with a field called authorization, and the value is the JWT, which we have from here, for example. But before the JWT, you also make sure to add the word bearer, just like this. That's just the standard of how we send authentication tokens. Now, we're not making this request yet. We're going to come back here to our code and we're going to actually write the logic to get that token from the headers and validate to see if the user's authenticated or not. Now, in every single middleware function, you have access to all of the same kinds of arguments that you would on a normal request. So you get a request, res, but you also get another one that is specifically important for middlewares. So we can get a rec, a res, but we can also get a next. And what a next is a function that when called basically tells the middleware to move forward with the request. So whenever we have the check to see if the JWT is valid, if it is valid, it means the user is authenticated, we can call this next function and it will move on with whatever the request is. So what we want to do is we want to first try to get the token. So I'll create a variable here called token, and I'm going to check to see if the request has that authorization field in their headers. So to do that, I can access the headers by saying rec.headers, then accessing the authorization field. Now, if there is a authorization field, and we need to make sure that it also starts with this bearer name over here. So we do that by saying if it has an authorization field, but also it starts with bearer, then we want to set that value to the token. So we're just gonna get that authorization token from the headers and we're gonna split it. How are we gonna split it? Well, we're gonna split it by the two words because we only want to keep track of the token. We want to ignore this bearer over here. And the way we do this is we know that there's two different words here. There's the bearer and then there's the actual JWT token. So we can split it like this. And what this will do is it will make it such that it's now an array of the word bearer and then the token, which I'm not going to write the token because you know. So what we want now is, since we have an array of two items because we split it based on the space that there is between the word bearer and the token, we can now just get the second element in the array because it's going to be the token. And so we ignore the word bearer. Perfect. Now, if for some reason the token is not in the header, we want to check to see if the token is in the request's cookies. So because we're setting it in the cookies, so we're going to add an else if here, and we're going to check to see if the request.cookies includes that JWT cookie that we created when we created the auth controller. Remember the cookie that we generated somewhere here? Yeah, over here. It's called JWT. Now, how do we do that? We access the request.cookies.jwt, and if there's something there, then we set the token equal to that. So request.cookies.jwt. Then, now that we have the token, we need to validate in case we don't. So if it went through both of these steps and it didn't set anything to this token variable, then there is an error and we don't want to move forward with the request. So we prevent the person making the request from actually executing on this endpoint. So it will run this before this, and if it doesn't have a token, it will never get to this. So to do that, we check to see if the token is valid. If not, then we return a response file.status401.json, and it's going to have an error that says not authorized, no token provided, or whatever you want to put for the error. Then, in case it moves forward with this, we know that there is a token and it is valid. So we want to verify and extract the user ID from the token. Now, previously, what we were doing is we were passing the user ID from the body, right? But we don't actually have to do that because the token already has that user ID. And I'll show you guys how to allow you to access this user ID in the Watchlist controller over here without having to get it from the body. Now, what we need to do here is we're going to add a try and a catch. And in the catch, we're just going to catch for any errors. I'll leave it empty for now. Now, in the try, I want to verify that the token is valid and extract the user ID. Now, how do we do that? Well, I'm going to decode the JWT token that we get from this variable over here. So to do that, I'll create a variable called decoded, set it equal to JWT.verify, and I'll pass the token, and I need to pass the secret that we created in our .env over here, the JWT secret, because that's what we used to create the token, and it's what we need to verify it. So I'm going to use process.env.jwt secret. Then when we get the decoded version, we can actually access the user ID, because if you look at how we set in the generate token, we set a field in the payload called ID with the user ID. Now that we have the ID, we can actually find the user and attach it to the request, so that for every request that requires authentication, we always have access to the user who made the request. So to do that, we're going to query for the user in the Prisma user table. So I'm going to say prisma.user.find unique, and I'm going to find a user where the ID of the user is equal to the user ID that we can get from this decoded JWT. So I'm going to say decoded.ID, and we get the user back, and we can check to see if the user doesn't come back. If it doesn't come back, then we're going to return an error again, but this error is going to be saying user no longer exists for some reason. So user no longer exists. This would reach this point if, for example, you signed into an account and you have the JWT on your cookies or on your headers for some reason, and you deleted the account, right? And then you make a request, and then it realizes that the account that is verified right now doesn't actually exist in our database. Now, if it passes everything, we can attach the user object that we get back from this into the request by doing this. We can say rec.user equal to user. So this rec thing that we get from every single route, it's an object that you can add stuff to it. Like, for example, we just added the user as a field here, meaning that in every route that uses this middleware, I can now access the user from the request. So when we use here the user ID, we don't need to get it from the body anymore. I can just get it from the user in the rec and access the ID of the user in that request. Same thing with any other. Actually, we're not really dealing with anything else over here. Oh, we are here. So if I do user ID, I can say rec.user.id, and it will work as well. Perfect. Now in the auth middleware, we are pretty much done. The only thing we want to do next is tell whichever request uses this middleware that everything is fine, the user is validated, and they can move forward with the request. So here's where we're going to call the next function. Now, in case there's any errors, we want to do the following. We want to return an error message. Now, we don't know what the error is, but the authentication failed. So I'm just going to say not authorized token failed. You can be more specific if you want to. You can use this error object if you want to, but I'm just going to do this. Now, at the end, we can export this and apply to our add to watch list route. And what happens is, let's go to requestly for a second over here, and let's go to this request. Let me try without passing this. So I'm not going to pass this. You can remove the headers that I just added by clicking on this button. And I'm going to remove the user ID because we don't need that anymore. And I'm going to click send. Now, the first thing is it's actually giving us an error. It says cannot read undefined reading JWT. So we definitely made a mistake in our auth middleware. So the issue was that we had to add a question mark here to the cookies because cookies might be null. So by adding the question mark, we are not accidentally trying to access the JWT when and cookies is null, because then it would cause that error. So it works. I can click send, and you see we get this error message saying not authorized, no token provided for the watchlist route, meaning that we are running this and we are detecting this. So we're getting it over here. Now let's try adding the token. I'm gonna go to the headers and I'm gonna click add. Now keep in mind, we're not passing the user ID over here. So when I click send, it says success, and it got the user ID from the correct bearer token. So this is how middlewares work and how authentication and authorization works when you're building your API. You create a middleware that is going to run. And now for every single route that we create, we can just apply this middleware. But you could also apply this middleware for just specific routes. The way we do it over here, we're applying it to every single route in this router. For example, instead of doing this, I could just apply the middleware by adding it as the first thing after the path definition on the route. This over here applies this auth middleware to this route and no other. So if I had other routes over here like this, they wouldn't be affected by the auth middleware. But most likely you want to detect the user is authenticated or not on all of your routes, other than obviously the auth routes, because you don't need to be authenticated to register an account. That wouldn't make any sense. But in all the other ones, you would. Now, I want to really quickly add 2 more routes that we should have on this router. Now, I won't show myself writing the controllers for them because it will be most of the same stuff we've done so far. I will show you the full controller created. However, I want to show you guys something. For example, if I want to create an endpoint where I am able to delete a item from my watch list, right? So I can remove an item from my watch list. Then the HTTP method that I'm going to use is the delete, because I'm deleting something. It's a delete operation. Now, when you make this request, we can just do it like this, right? Where it's in the index of the router, just like how we did the post, and we can use the same because it's a different method. Now, when we try to delete a movie from the watch list, we need to get the information about the movie that we're trying to delete. Now, to get that information, which in this case is the ID of the movie we're trying to remove from the watch list, or the ID of the watch list item, we usually in a post request, for whenever we want to send data, we send it through the body, right? And then we do rec.body, and that's fine. However, when you're working with other types of HTTP methods like a put or a delete and so on, you usually don't want to send the ID through the body. It's better practice that instead you send IDs through the params of the route. Now, what does this mean? Well, basically, if we were to make this request, right, it would look something in the lines of this, right? It would be the base URL, so base URL, then slash watchlist, I believe. Let me go to requestly to check it out. Yeah. And then if this is a delete, this should be enough, and then we make a delete request. But I can insert the ID of the watchlist item I want to remove inside of the URL of the endpoint. The way I do it is by adding a param that will exist at the end of the endpoint. So a variable that goes over here, and then we can just put the ID just like this. Now, the way you define this is by defining a param variable as follow. You give it a name with a colon, and you define it over here, just like this. And now when I make this request, this delete request, which I'm gonna do it right now, I'm gonna duplicate the add movie, and I'm just gonna change the title to say remove movie from watch list. Now, the reason why I'm doing this is so that I don't have to repeat all of the stuff that I was doing before. Now, what I want to do is I want to copy this this authorization token over here. So I'm gonna copy this bearer, and I'm gonna go to the remove, which by the way I have to change the name. I just realized I wrote it wrong. And in the headers, I'm gonna also add the bearer and the token, and I'll add the authorization, because you can only delete if you are authenticated, right? Now, I'm not gonna send anything in the body, but when I make this request, which is gonna be a delete request, I'm gonna include the ID of the watchlist item I want to remove directly over here. So let's go into our database and let's go to the watchlist item. There should be only 2 items, and let's get one of them to remove. Let's delete the one from, I don't know which movie this one's related to, but I'm going to copy this, the first one, and I'll put it over here. Now, if I do this, then this variable that we defined over here, this ID, will be set to this exact value that we pass over here. And why is that important? Because then when we create our remove from watchlist controller, which just like I just said, I already created it. I'm going to show you guys what I did for it. It's this over here. Then we can get that ID by doing rec.parems.id. And we can do all of the other operations that would require us to delete it. Now here's the remove from watchlist controller, which you can get from the code in the description. I'm just deleting that item from the table, and I'm checking to see if the user is the owner of the item before actually deleting. Now we can try to see if this works if I do send a request over here. Okay, I just ran again and it worked. You see it deleted, and then I tried deleting it again and it said watchlist item not found. So we'll come back here, we'll refresh, you will see that it should only have one. Now let's delete the other one. I'm gonna copy this and I'll come here. I'm gonna add this over here and we'll try deleting this new one. And you see success removed. If I refresh this, we should see that there's nothing over here. So it seems to be working perfectly. And I also can create a similar type of route for the update, for example. I could come over here, I can create a put request and then call the update watchlist item controller that I created on this controller file. And you can take a look at it. Again, it's just updating something about the status, the rating, or the notes. It's more of what we've already done before. So I'll leave it up to you to check it. Now, we're going to move on to the next topic that is important for you to fully understand when you're working with APIs, and that is validation. Now, what is validation? Well, every time we have a router, such as this one over here, right? The route for adding to a watch list, it has a body. But when we get this data for the body, you might have noticed that a lot of times I'm saying that we're assuming that the user will send these values. Now, what happens if, for example, the user sends a request and it doesn't include a movie ID, or it doesn't include the notes or the rating, or maybe it includes all of that, but for some reason the status is a number instead of a string, or the rating is a Boolean instead of a number. So you have to validate that the body matches the schema of what that body should look like when you get the request. And to do that, you can apply some validation through a middleware. So what we want to do is we want to come over here, and in the middlewares folder, we want to create a validate request middleware. Now this middleware will be applied to every single route that requires us to pass a body to it, right? And it is going to have a specific schema for each route that specifies the types that we want to get back from the body. Now, how do we do that? Well, before we even write anything on this middleware file, we have to install a package that we're going to be using for validation. There's a bunch of them out there that you can use. There's Yup, it's a good alternative. There's Express Validator, that's a good one as well. But one of the most popular in the market is Zod, and that's what we're going to be using. So to install Zod, we're just going to say npm I Zod. It's going to install it. And then what we want to do is we want to create a folder for where we're going to define all of the validation types and schemas for each of our routes. So for example, we have auth routes, movie routes, and watchlist routes. So we're going to create a folder called validators that is going to contain a validation file for each of those routes. Now, some routers might not require any validation, so you don't need to create for those. But in this case, we're going to create here the watchlist validators. Now, in the watchlist validators, we will define the schema for each route that includes a body in the request. So that means we're going to create one for this one, which is the add to watch list, which you remember has a body. And we're also going to create for the put. We didn't go into detail about this one, but you can see that when you update an item on your table, you need to send the data of what you want to update on top of also sending an ID to identify which item you want to update. So this one also requires a body. The delete doesn't require a body. We only pass information through the param. So in the watchlist validators, we're going to start by importing z from Zod. Then with this z object, we can define a schema for each of those routes. We'll start with the create watchlist item or add to watchlist schema. To define a schema for a body, you just do z.object object. And inside of this object, you define everything that you expect from that body. So if we go here to the add to watch list, you see that when we make this request, we require a movie ID, a status, a rating, and any notes. So we'll add here first the movie ID. Now we want to specify what are the types and any types of specifications like lengths and like whatever you want to do, amount of characters you want for this specific field. For example, the movie ID is a string. So I'm going to say that this requires it to be a string. Now, the next thing we want to validate is that movie ID is not just a string, it's actually an ID. And there's a standard for IDs that is used everywhere. It's known as UUID. So you can actually verify if it's a UUID by using this UUID function. Now, after this, we want to validate the next type, which is status. Now, status is a cool one because if you remember from how we defined it in our schema over here, the type has a very specific structure, right? If you go to watchlist status, it's an enum that can be planned, watching, completed, or dropped. So what I want to do is I want to make sure that this status is an enum, just like how we defined in the table. Now with Zod, you can define an enum by using the enum function and passing an array with all of the options. So we can say that it accepts a planned, it accepts watching, it accepts completed and dropped. And then if it actually isn't one of these options, we can specify an error message that will show up whenever we validate this. Now, how do we specify that error message? I can add an object over here, and that object will have an error. Now that error I can define as a function that I can return as an object. So I can put a parentheses around here. And why do we need this function? Because I can specify a message, so the error message, and if it's not one of the following options, I can return the following. Status must be one of. Now you'll see this error message appearing exactly how we wrote it. Now also status is optional, right? We don't need to pass a status always. It's optional. So with optional fields, you can actually add an extra thing at the end saying that it is optional, and it will allow us to not pass a value for it. Now the next one is the rating, and the rating is a number. But the thing is, if I were to just do here z.int to validate that it's an integer, then if for some reason I sent a rating through the body of 8, but as a string instead of a number, this would error out. And with this kind of situations, you can use your best judgment. Do you want to allow something like this or only allow something like this? Well, let's see how we can allow both. To allow both, you can actually convert string numbers into numbers by using the coerce function and coercing it, the string to become a number. Then you can validate to see if it's an integer, and you can put in a specific error message. If, for example, instead of passing a rating of 8, the API, the requester passes a rating of 8.34, which is not allowed. So the error message comes over here as a string. We can say rating must be an integer or something like this. Now we can also set a minimum value if you want to. So I think ratings should go from 1 to 10. So I can say that the minimum is 1 and the maximum is 10. But also the ratings are optional, so I'm gonna do optional over here. You can also put an error message if you want to, a specific error message over here. You just add a comma and put something like rating must be between 1 and 10, and then maybe add the same error message appearing over here. Finally, we can add the one for the notes. For the notes, it's gonna be simple. We're just gonna say that it has to be a string and it has to be optional, or it can be optional. Perfect. Now we created a schema for how the body of the add to watch list controller should look like. Now, what do we do with this? We have to apply it. So I'm gonna export here at the bottom the add to watch list schema, and I'm gonna go back to this validate request middleware that we created. Now, this middleware will be super important. What we want to do here is we want to create a function called validate request, and it requires us to pass a schema inside of it. And what this middleware is going to do is, based on that schema, it is going to either allow the user to continue moving with the request, or basically return back to the requester, to the client or the front end, a message with the specific error message of where they are failing the schema check. So to do that, we're going to return a function inside of here with where we can access the request, the res, and the next. Now, why are we doing this and not just getting this over here? Because we can't, since we are making a middleware that already has another argument. It doesn't have this specific arguments. So you know what I mean? You'll see what I mean when we actually apply this. But the actual middleware function is this. This is just the function that we're creating to get the schema first. Then what we want to do is we want to actually check to see if the body of the request passes the schema. To do this, we create a variable called result, and then we can access the schema from the argument here. And since the schema that we're going to pass here is always going to be of this type, so it's going to be a Zod object. The Zod objects contain this function called safe parse, which if you pass an object over here, like the body, it will check to see if this body matches the requirements of the schema. Then if the result.success, which is a Boolean letting us know if it passed the check, is not true, then we don't want to continue with the request. We want to actually return an error with a status 400 that has a JSON with a message equal to whatever the error messages of the schemas are. Now, how do we get those? Well, to get the error messages, because you can actually fail multiple at once, right? I can not send a movie ID and also send a decimal for the rating, and then it fails 2 times, and we want to get all of the error messages. To do that, we're going to create a variable here called error messages, set it equal to result.error, and then we can access the errors, which is an array, and then map through all of them so that we only get the message. We don't get anything else. Now, what we do is we want to actually join all of those error messages through with a comma. So I'm going to get that array called error messages and join each item and apply a comma and a space so that now I just have one single string with all the errors and I can apply all of them directly over here. Now, what happens if it is a success? So we didn't reach this case and it is a success. Well, then we can just call the next function and move forward. Now, what we want to do is in our route over here, the watchlist route, we want to import this validate request middleware and apply it before we call the controller just over here. Now, again, we're not applying it like we did before by using the use function, because not all of the routes actually require a validation to happen. Only the post and the put, the delete doesn't. Now we're going to apply this middleware to the post, and because it requires a schema, we need to pass a schema for this specific route. Now what schema is that? It's the add to watchlist schema. Now what happens is if everything is right, it should be validating for us. Let's try this out. I'm going to try adding a new movie. I'll just add this to our table, but I'll make some changes. For example, for the rating, for the status, I'm going to put something random over here. Let's see what happens. Okay. So there's an error in our API. So the issue is that we actually need to flat and format our error messages. I found this in the documentation for Zod. For some reason, I think this is coming with the new version of Zod. Basically, all we have to do is do this with the error messages. We first format the error by getting the result.error and then using the format function. Then we flatten the errors by using the flat function, filtering out any booleans, mapping it into the errors, and then flattening it again. And then in the end, we can just return a join of all of that. And if we were to come to Requestly and run again, you'll see that we do get the correct message, and it's specifically the message that we put in our watchlist validator for this enum. Perfect. Now let's see what happens if I put a correct status, right? But what if I put this and then I put, for example, 8.9, which isn't an integer? Perfect. Now the error message says rating must be an integer. What if I do everything correctly? Boom, everything is fine, and we should be able to see it appearing over here. So this is pretty much it for validation. You want to do this for every single route that requires a body. And this is pretty much it. I went over a lot of different topics. So if you were a complete beginner when you watched this video, now you have a much better idea of what an API is, how to create one with NodeJS and Express, all of the intricacies of building one, you've learned about setting up your server, connecting to your database, the different ways to organize your project, how to properly handle closing your server and exiting it, how to create different routes, and how to organize your routes such that they're not just a blob of code, but rather just a place to define the routes, how to separate your project into controllers so that you have your logic, your actual logic presented over here, how to protect your users by implementing some sort of authentication, utilizing modern technologies such as JSON Web Tokens and hashing. Also, you guys learned how to actually authenticate and authorize the users by utilizing an auth middleware, and also how to validate your requests by utilizing a validation software such as Zod. Now, I added over here to this project a lot more. I'm going to link this together with the code. It's going to include some other stuff that you might want. For example, an error middleware where you're able to specify how to like deal with different errors. This is a little bit more advanced, but I added here some comments to help you out. And I also added more stuff like more validators that I think we didn't implement in ours, but you would want to as well in yours, for the registering, logging in, and also some routes for the movies, which we didn't get to in this video just because it would get repetitive, but you would do that in the final API as well. Now it's time for us to deploy our API. And before we do that, I want to make a simple fix with the code that we currently have. And that's actually because if you look at our code, when we listened to our API over here by using the listen function, we actually never created an instance of our server. Now, why would we need that instance of the server since everything seems to be working fine? Well, it is working fine. However, if you look at all of our processing over here, our listeners that are listening to events in which we maybe want to close our server, we are using this variable called server to close it. Now that server variable only exists if we create that variable over here. So we'll create the server variable and now this should work. Perfect. So now we're ready to deploy our API. Now what I want to do is I want to go here to our browser and go to hostinger.com. You can just click the link in the description. This is where we're going to deploy our API. Now, if you've been watching my channel for a while now, you know how much I enjoy using Hostinger for deploying my applications. I've deployed apps on Hostinger. I've deployed full stack apps. I've deployed front end, back end, everything that you can imagine, because they do have a solution for absolutely everything. Now, I highly recommend you hosting your APIs on Hostinger because they have really good plans for VPSs. So if you go to hostinger.com/VPS hosting, or just click the link in the description, you'll be able to see that at least for right now, they have a really good Black Friday sale where you can get 67% off your hosting. If you were to claim their deal, it can go up to as little as $4.99 a month. And I highly recommend that you guys choose this plan over here, the most popular one with the KVM2. Now that's the plan that I'm choosing for this video. It is a lifetime deal. You can choose. It's going to be $5.99 a month. You're going to get 2 vCPU cores, 8 gigabytes of RAM, 100 gigabytes of an NVMe disk space, and 8 terabytes of bandwidth. So if you have an API you want to deploy, this is a great plan to choose. You just click on choose plan, and then you're gonna get to this page over here. The longer you choose the period, the cheaper it's gonna get. So like 24 months, it ends up being $5.99 a month, and if you're in the US, you save $288. If you choose 12 months, it's going to be around the same price. However, you're going to get this deal for longer if you choose the 24 months. And one important thing for you to understand is that you actually get a free domain if you get either the 24 or the 12 months. So if you just get 1 month, you're not going to get a free domain. And that's really good because a domain, as many of you might know, can cost upwards of between $10 to $20 a year. And you get one completely for free if you choose to get 12 to 24 months of your KVM. Now, there are other options over here if you want to choose. Daily auto backup. It is recommended that you do get that. However, for this video specifically, you don't actually need that, but I do recommend it. Then select the server location. You need to choose the location that is closest to where your users are going to be. So think of who is the user who's going to consume your API, and then think of where they are, and then choose the location that is closest to there. Because depending on where you are, for example, I am in Canada, which is the west of the United States, or the west of Canada, but like you get what I mean, because they don't have a location in Canada, I would choose Phoenix, which is the closest location. So there's a best latency for me. Now, if my users were in India, I would then choose somewhere in Asia, most likely India, right? Then you need to select your operating system. Now, we are going to deal with all of that later as well. However, if you want to choose it right over here, please select Ubuntu and select this version over here. So click confirm, and then when you come here, you click on have a coupon code. And if you use the coupon code PedroTech, not only you're gonna get all of the Black Friday sale that you already have, but you're also going to get 10% off your order. So feel free to do that. Now you just click continue and you create your account and pay for it. Now, when you're done with that, you're going to be brought to the panel, and that's where we're going to continue for the rest of the video. Now, when you do sign up with an account, you're going to get a bunch of things. Now, I already have my VPS over here, and what we want to do is we want to click on setup. Now, setup is going to open up the setup instructions for our deployment. You want to choose a server location, and it is highly recommended that you choose a location that is as close as possible to where the majority of the listeners to your API, so like the people who are actually going to make the requests to your API, where they are. So like if you are someone who is in Europe and your audience, your API users are going to be in Europe, make sure to choose a country or server location in Europe. If you're someone who's in Asia, you're in India, choose the one in India. Now, I am in North America, and I'm just, testing here. There's nothing in Canada, but the closest we have here is Phoenix, which it says over here that the best latency is going to be 52 milliseconds, which is extremely good. So I'm going to click here next, and it's going to ask us to choose our operating system. Now, why do we need this? Well, to explain to you guys this, I want to first just quickly explain what a VPS is and why we even need one to deploy our REST API. Well, a VPS stands for a virtual private server. So it's basically, we have our API running here locally in our computer, and a VPS is basically a computer, just like our local computer, but that it's in the cloud and we can control. So we want to launch this VPS that will be existing in the cloud, and we will basically restructure our project. We'll reinstall all the things that, all the dependencies that we have in our project, but on this new computer. And whenever someone makes a request to a specific domain, which is the IP address of where our API is going to be hosted at, then they'll be able to access our API and request the data that we created. Think of it as like a mini computer that is always online, and we can install everything that we want inside of it, like NodeJS, Express, all the, Prisma, all the kind of stuff that we installed in our own project. And we can connect to that computer by utilizing what is known as SSH, which is a way for us to control a virtual private server. Now, to create this VPS, which again is just a computer, we need to choose the operating system. And they have a bunch of options over here. You can choose between the different options. Now, what I would recommend is for you to choose Ubuntu, which is a computer operating system based on the Debian Linux distribution. I bet all of you guys have heard of Ubuntu before. Now, the version, you can choose whichever one you want. I'm going to choose the 24.04. I'm going to click on select, and it's going to ask us to secure our VPS access by setting a root password. And also, if we want more protection, we can add an SSH key for that extra layer of protection. So we are going to put a root password over here. Now, obviously, I recommend that you create your own, and I recommend that you make it extremely hard for someone to guess it, because this is what is going to allow people to control your entire VPS. So if you want to choose something that you personally just write whatever you want over here, or you can also just click on this button, which allows you to generate a password. Now, I'm gonna copy this password and I'm gonna save it on my computer, and I would recommend you doing the exact same thing. Now, the next thing is we want to set up an SSH key. So what is an SSH key? Well, an SSH key is basically a password file that your computer is gonna use to log into the server without you having to manually type in the password. So this is gonna come in two different parts. You're gonna first have your private key, which you keep on your computer. It's like as if you're in real life, you had your house key, the one that you keep with you. And there's also a public key, which is what is actually stored on the VPS. Now, when you want to SSH into your VPS to do something with it, like control it, you're going to give the private key and the server is going to detect whether or not it matches the public one. And that will determine if you are able to SSH into your computer or not. Now, you can select an SSH key if you want to over here, or you can click on add a new SSH key. Those are ones that I've had from the past. You can click here on add new, and they have really clear instructions on how to actually create or generate an SSH key for yourself. We're going to do this. So I'm going to open up a terminal and I'm going to run this following command. Now we're going to paste this over here, and I want to replace this command over here with our own email. So I'm going to use the email that I'm using on my Hostinger account. It's my business email. I'm going to press enter, and it's going to ask which file we want to generate our SSH key in our computer. Now it's going to be this file over here. I already have an SSH key on my computer, but I'm going to press enter either way. So I'm going to try to override the one that I already have. It's going to ask for a passphrase. I'm going to put my own passphrase. I recommend you putting something as well. I'm going to press enter, and it's going to ask for the same passphrase. Perfect. And then it says your identification has been saved, and here is the path in your computer for that file. Then what we want to do is we want to navigate to our SSH folder in our computer. It's this .ssh folder over here. If you're on Windows, this might be slightly different. But what we want to do is do cd and then go to .ssh. And this basically takes us to the root of our computer. So in my computer, it would be this. So I'm just going to the root and then going to the SSH folder. Then in here, if I were to open this, actually, let me just ls. You see how we have a bunch of files over here, right? This is what exists in the SSH folder. If you go back here, you see that they recommend that we open the .pub file with a text editor. This one over here, this is the one that we just saved, right? Our SSH key. I'm going to do open dot. It's going to open this up over here. Then I'm going to close my terminal, bring this file into my text editor. I'm going to open it, and I'm going to copy whatever is in here, go back to our computer, to our browser, and I'm just going to paste it directly over here. Now, we want to put a name. I'm going to call it Backend Course REST API. Then I'm going to click on save, and this should be it for our root password and our SSH key. I'm going to click next, and because we set up, we purchased the plan, it actually allows us to have this free malware scanner, which allows us to keep our VPS safe in case we potentially download a virus on our virtual private server, which is a real problem if you don't have something like this. I am going to add it, and I'm going to click on finish setup. Perfect. It is setting up our VPS. According to them, this will take around 3 minutes. Usually it goes a little bit faster. I'm just going to cut to when this is done setting up. Perfect. As you can see, it went pretty quickly. We are done and ready. And we can see that we can access the VPS dashboard by clicking on Manage VPS. I'll open that up. And we can also access our VPS by using our terminal and using the SSH command, which is what we just spent the last few minutes setting up in this video. Now, what we want to do is we want to copy this and use it to SSH into our computer. So I'm going to open this up over here in our terminal, and it doesn't matter where you are over here. We want to paste the command and press enter. Now it's going to ask for the authenticity of this host. Now I'm going to press yes, because I want to authenticate, and it's permanently adding that host as to the list of my known hosts. Now it's going to ask for the passphrase that we just created for that SSH key. I'm going to put my own, the one that I set up, and because it's correct, we have officially entered into our VPS. Perfect. Now, what does this mean? It means that we have SSH'd into a computer that is in the cloud, and we can do whatever we want over here. Now, what we want to do is we basically want to have a copy of this project that we have here in our computer, and we want to have that in this computer in the cloud. And not only that, but we want to be running that at all times. It's almost like we run the local host that we have over here in our computer, but on the cloud, and it's always running. And whenever someone connects to the IP address of this VPS, then they will be able to access that REST API. So that's amazing. The first thing we want to do is we want to install all of the necessary dependencies for this project to even run. So the first thing we want to do is we actually want to run the following command. I want to run apt update and apt upgrade, and I'm going to put a -y. Now, what does this do? This will basically refresh the package list. This is Ubuntu command. It's not an actual package that is installed. It's part of the computer operating system, and we're refreshing the package list of our server, and so that we can later on install the latest versions of every available software in this computer. So I'm going to run this. It is just going to refresh everything, and when that's done, I'll be back. Perfect. So it finished doing that, and now we want to install the most basic core essential tools that we need for this project to run. So if you remember, when we set up this project, obviously we had to have Node.js installed, and if we're going to be pushing this code, we'll have to have Git installed as well. So we do need those two essential tools to be running in our project. Now, before we even install Node.js, we're going to install two very core packages. To install them, we're going to use apt install-y, and what we want to install is, first we want to install curl, which is a package that allows you to download stuff from the internet. We're going to need it to actually install Node from Node source. Then the next thing is we want to install Git. Why? Because to have this project that we have in our computer exist on the computer in the cloud, we need to push this code into a Git repository and then clone it in the virtual computer. Now I'm going to press enter over here. We're going to install them. Perfect. Now we need to download Node, but before we download Node, we have to download the Node installation script by using curl. So we're going to run the following command over here, and it is going to install the installation script. Then to actually install the repository that we just curled, we have to run an apt command to install Node.js. Perfect. So it finished running. We're going to run apt install-y Node.js. Perfect. So it is going to install Node.js into this computer. Perfect. Now, to check to see if it's actually installed, we're going to check to see what version of Node is installed, and it is 24.11.1. We can, because we have Node, we also have npm, which is the package manager for Node. So I'm going to run npm-v, and we also have this version, and we're pretty much ready to be able to run a Node.js and Express API in this computer. Now, what do we need to do? Well, we need to get the code that is here in our computer locally into this cloud computer. So what I want to do is I'm going to open up a new terminal here. I already had another one open. Make sure this one is actually in your computer, not in the SSH one. And we want to create a Git repository by running git init, then running git add dot. Then you should go here to GitHub, create a GitHub account if you don't have one, and click on create new repository. We're going to give it a name. I'm going to call it NodeJS ExpressJS backend course, but that's just because this is where you guys found the code for this video. Now call it whatever you want and click on create repository. Then you will see the following commands. I'm going to copy this over here where it says git commit and everything but the git add and the git init. We're going to come back over here. I'm going to paste this, and we're going to push that code into our repository. Perfect. Now that code exists over here. Now make sure, because we have our git ignore over here, we're not actually pushing our .env because we don't want to push this file since it has all of the private details like the database URL and our JWT secret. So make sure it doesn't send that. You can see that we don't have that over here. Now what we want to do is go back here, open up our terminal. Now we want to create a place in this virtual computer where the code is going to exist. And there is a common Linux convention for this. It's going to be the /var/www directory. Now to do that, we have to create that directory because it doesn't exist already in the computer. So to create this folder, this directory, we have to run the command make directory, then -p, and then put the directory name. So it's going to be /var/www. Now, when I run this, we should now be able to access it. So I'm going to run cd var/www, and you see that we are now inside of that directory. Perfect. Now I'm going to create here another folder. Let's do make directory, and I'm going to call it backend course, just because it's the name of where we're going to have this this project. Now I'm going to go inside of that new directory, backend course, and inside of here I want to clone our project. So I'm going to come here to GitHub. I'm going to copy this command over here, this one. And I want to run git clone this and then put a dot in the end so that it doesn't make an extra folder. It just clones it directly into the backend course folder. And it will start cloning our project in this virtual computer. Now, when it's done, what we want to do is we want to create that extra file that doesn't exist in our GitHub repository, which is the .env, because we obviously didn't push that here. So when we cloned that repository into here, it doesn't actually contain that file. So to do that, we want to create a .env file in this server. Because I'm using Mac, I can create a file by using nano and then creating a .env file. Now it's going to allow me to write into this file over here, right? Directly over here. Now that means that I can copy whatever is inside of this .env file. I'm going to copy this entire thing over here. And actually, let me just change this. I'm going to change this to production just because we're going to put this in production, and I'm going to paste it over here. Then I'm going to basically put Control X to exit, Y to save, and then press enter to save it. Now, I know that's a lot of stuff. If you're not familiar with Nano, I recommend you asking ChatGPT exactly the commands. It's because it's hard for me to explain because I'm using my keyboard. But regardless, you should have a .env file existing over here. If I were to run nano.env again, you'll see that all of the variables are here. And I can just quit by, again, pressing Control X on my keyboard, and it will close that. Perfect. Now, the next thing we want to do is we want to change a bit of our code. So if you go here to our code, we have the following. So we have port 5001, and that's the port that it is listening to. Now, instead of that, we want to make sure that this is going to be listening to a port that matches the one from the computer. Now, internally, if we, instead of making a variable called port, we were to do something like this, process.env.port, then this over here would be set by whatever our VPS is going to decide. Now, internally, when we are developing, we can obviously set in our own .env file this port to be 5001 if you want to, by just creating this variable over here and then setting it to be something else like 5001. But when we actually have this in production, it's not going to be like that. Now, the next thing we need to do is we can default something over here, like we can make it 5001 if nothing is set. Also, we need to make sure that the API listens to the following. It needs to listen to 0.0.0.0. Now, why? This looks pretty random to be honest, but it's because the VPS is not our laptop. So when we run the Node.js locally, you know that the API will default to be running on our local host. But when it's on the VPS, it's not on the local host. Instead, when we set the 0.0.0.0, we're basically telling Node that we want to accept traffic from any network interface, not just our computer. So this will include things like our local host, like we did before, but also like external public API, IPs, private IPs, load balancers, our domain, actual users, all that kind of stuff. So it's essential that we do this. Next, we need to actually push this code again. So we made some changes. So I'm gonna add commit. So say fix and then push this, which means that in our own code over here, we need to pull the new changes. So you see there were some changes to our server.js. And they are present now. Now we're almost done. What we need to do now is we need to install our dependencies, because you see over here, there's a package.json. And if I nano that package.json, you'll see that we can see the package.json that we have in our actual computer here, right? It has all of the dependencies that we installed, but none of those dependencies are actually installed in our VPS. So I need to install them by running npm install, and it should create the node modules folder that we need to have all of the dependencies actually working. Perfect. So it seems to have installed everything. I'm going to clear this. Now we're ready to actually run our API. Now we can run the command node source server.js, and it's going to run our API. Now it does say port undefined, but that's fine. It isn't undefined since we didn't put a port on the .env file in our VPS. It is saying that it's undefined, but if it's undefined, it defaults to 5001, so we know that that's the port. And we don't need to worry about setting a .env port in production. It's actually recommended that you don't do that. Now, what do? We have this running on our virtual private server. So what does that mean? Well, it means that if I go here to our, so I'm going to click on Manage VPS. This is our computer that is running. What I want to get is I want to get the IP address of our VPS. Now, why do we need that? Because then we can actually curl and put the IP address on Requestly to make the requests onto the API running on our VPS instead of the one running in our local computer. Now, the way I do this is I go here to our H panel in Hostinger, and if I scroll down a bit over here, you'll see a bunch of details about the VPS. One of the details we need is the IPv4, which is the IP address of it. So I'm going to copy this, and in my own computer, I'm going to open up Requestly over here, and I'm going to make a test request. Actually, no, let me just register a new user, because that's one that we don't need any authentication. Now, the base URL over here, it's going to be something different, because now we are not making a request to the localhost 5001. So I'm going to click here on our collection, go to variables, and I'm going to add a new variable called prod URL. And in here, I'm going to put the following. I'm going to put HTTP // and then the IP address of our server, and then the port in which it's running, which in this case is going to be 5001 because it's what it defaults to. Then I'm going to copy this, paste it again, save it. Then I'm going to come to register user, and I'm going to use the prod URL instead of base URL. Now let's create another user over here. I'm going to create a user called, Jack, and then with the email jack@gmail.com, and I'll use the same password. If it's working, then we should be able to send this request. And as you can see, we successfully sent this request, and it created a user called Jack. Now we sent this request to our prod URL, and if we checked our Neon database, that user is here. So we made all of this happen, not from our local computer. In fact, I don't even have the project running on my local computer. There might be some, I can see some Prisma errors happening on the VPS, but it seems to be working perfectly. So we successfully set this up. Now there's a couple more things we do want to do. This was just for testing. So I'm going to kill the server by doing Control-C. So it's just for testing to see if this was going to work. And it did. Now we want to make it such that our API will keep running. So our Node app will keep running no matter what. So when we have it locally, and even when we have it on our VPS and we just run our app by doing Node and then the name of the file, it will keep running as long as our terminal is open or our SSH session is open, and as long as the server doesn't reboot or our app doesn't crash, which that's a bunch of ifs, right? Because in case any of those things happen, then our app will stop running, and then no one can actually make requests to our API, and that's not a good experience. What I want to happen is, even if the VPS reboots, even if I disconnect, if Node throws an error, if Linux kills the process, our API shouldn't die. Now to do this, we can use what is known as a PM2, which is a process manager for Node.js apps. It will make sure that our API will run in the background, it will restart automatically if it crashes, and all that kind of stuff. Now to do it, what we have to do is we need to install this package manager here. So I'm going to run PM2. Oh, actually, I need to install it first. So I'm going to do npm install globally PM2, and it's going to install inside of this computer. Perfect. So it installed, and I just have to run this once per VPS that I have running. So I just need to run this once, and I can close my SSH, and this app will keep running forever. So I killed that server. You see here in request that if I were to send this, it wouldn't work because obviously it's not running. But now I can start the app by doing PM2 start, then putting the path to that server.js file. So I'll do source/server.js, and then I'll give a name to this project. So I'm going to call it movie watchlist API. This is not what we had to do. We had to first put name over here. So we're giving it a name, and then that's the name we want to run. I'll press enter, and as you can see, it is running, it is online, and even if I kill this SSH, it is going to be running. Now, what I want to do is I want to do npm2 save to save a snapshot of all of our apps that are currently, that PM2 is currently managing. Now, the next thing is I want to make it such that PM2 will run automatically at whenever this VPS boots. So I can run PM2 startup systemd, and this will make it such that no matter what, when the server turns on, then it will automatically start PM2, which will obviously automatically run our project. Now, again, this all should only be done exactly one time in each VPS. And now it's pretty much done. So what does this mean? Are we completely done with deploying this? Well, kinda. So if I were to kill this SSH over here, right? I just killed it. Then I come over here and I were to create the user Jennifer. I don't even know if that's how you write Jennifer, but I'll create here Jennifer at Gmail and I click send. You see that we created that person, even though we killed the SSH which wasn't working recently. That's because of PM2. Everything seems to be working. We just have to make requests to this specific IP address. And for a lot of people, this might not be fully enough with deployment, just because this isn't a readable URL. It is deployed. You can make API requests to this port, to this specific API. However, we want to actually make requests to a domain, right? To do that, you have to have a domain. Now, the great thing is that because we bought a plan from Hostinger, we're going to get a completely free domain. So I'm going to click here on domain portfolio, and it says that I can register a domain for free for 1 year. So I'm going to click on claim domain. It's going to ask me for a domain name. So it's going to be a .cloud domain because that's what comes with the plan, and that's totally fine. That's a great domain. I'm going to choose something like this. I'm going to call it movie watchlist.cloud. Let's see if that's available. Surprisingly, it is available and it's $0 a year. Perfect. Now we just claimed this domain. Hostinger is going to finish the domain registration for us. It's going to be completely fine. And I am absolutely ready to start using my domain. So I'm going to click on continue. I'm going to skip all of this and make sure that you verify your email within 14 days, or else they won't actually keep your services active. Now, what we need to do is after you verify this, which I'm not going to do it right now, you go to DNS name servers over here, and we want to add a DNS record on this domain that points to our IP address of our VPS. Now we want to add an A record, and I want to call it API. Then I want to get the IP address that we can get here from our H panel, the VPS IP address, go back over here and then point it to this. Then I'm going to click on add record. Now we click confirm, and it is going to create this API name on our DNS records. And what this means is I can now curl, or I can now make requests to the endpoint, to the endpoint with the domain name moviewatchlist.cloud with an API in the front. So this means that I can change my prod URL again. If I come here, change this to say, instead of this, it says API, and it says API because we called this API. Then do .moviewatchlist.cloud, and then do the exact same thing over here. Save it, and then go to register user, and I try to create Jennifer2, and I click send. The reason why this is happening is because if we come here to our prod URL, right? If I click here and then go to variables, we're not passing the port over here, the port 5001, which is that port that we defined. If I were to do this and come here to register user and run again, you see that we actually were able to make a successful request to an API using the domain that we just set up, and it works, right? If I go here to our database, it will be over here. Now you might be asking yourself, why? Like, okay, we now have this domain, but why do I need to specify the port? Well, that's because we are not using something called Nginx. And Nginx will basically allow us to be able to make a request to just the root without having to put the port, and it is going to work either way. Now, if you don't care about that, then you don't need to watch the rest of the video, but for the rest of the video, we're going to be working with Nginx to be able to do that. Also, in the end, we're going to be able to make this be encrypted and be an HTTPS instead of an HTTP. Now, when we make a request to something without a port, this is basically listening to the port 80, which is the standard HTTP port. So what it's going to do is it's going to forward the request to our Node app that is running on whatever internal port we set, which in our case was the 5001. Now to do this, we need to go back to our code and re-SSH into our our computer. So I'm gonna SSH into it again, put my passphrase, and when I do that, okay, perfect. Now I want to cd into /var/www, perfect. Then cd into backend course. I believe that was the name of the, yeah. And then, yeah, we're inside of our project. Now I want to do apt install. Actually, I just realized we didn't need to get into this project, but we're here anyway. So I'm going to do apt install -y, and we want to install nginx. Now with this, it's going to install nginx into this VPS. When it's done, I'll be back. Perfect. So it's done. I'm going to clear it over here. And what we want to do is we want to create a config file inside of this computer. And I'm going to make a config file that is going to exist on a folder called etc/nginx/sites-available/ and then you give the name of your project, which is going to be backend course or movie watchlist. Let me call it movie watchlist. Perfect. Now inside of this file, I want to paste the following thing. You can write it yourself or copy from what I'm going to put in the description. Basically, what this nginx file is going to do is it's going to listen to the port 80, right? So any requests, and the server name is going to be the domain for our server, which is api.moviewatchlist.cloud. Then it's going to proxy pass every request to the API that we have running on our local host. So this 127.0.0.1, basically the same thing as a local host, and we're running it on port 5001. So that's what we're going to do. All the other stuff is just basic nginx jargon, so I won't go into details. And then we'll do Control X to exit and save it by pressing Y, and then press enter to finally create this. Perfect. Now, what do we do? Well, now we need to enable it. To do that, I'm going to run the command ln-s, then put this entire path over here, just like this. And then I'm going to paste it again, but I'm going to change it from sites and available to sites enabled. Perfect. I'm going to press enter. That's great. Then I'm going to remove the sites enabled. I'm going to, again, come back over here, delete this, say enabled, and then delete the file or folder from the default. Then I'm going to run nginx-t, and it says that it's successful, and we can run systemctl restart nginx. Perfect. Now, this means that if we go here to requestly, and I remove this 5001 from here, I remove this 5001 from here, I save it, I come back to register user, we create Jennifer3, and I click send. You see that this also is successful. So we have successfully made it such that our REST API is deployed with a domain that doesn't require us to be putting a port. It's just like any other API. You can just curl this. You can actually do it yourself. I might remove the ability to add stuff to the database just because I don't want you guys spamming the database with stuff. But the last thing I want to show you guys is how to set up HTTPS with this, because we don't want to be really making requests to an HTTP URL. And to do that, it's actually extremely simple. I'm going to come here back to our computer. I'm going to run apt install, and I want to install a package called certbot, and then another package called Python3 certbot nginx. When that's done installing, I'll be back. Perfect. Then I'm going to clear this terminal, and I want to run certbot --nginx, then -d, and then the name of our domain. So api.moviewatchlist.cloud. Perfect. Then I'm going to press enter, and it's going to ask for our email address. I'm going to put my email address. Then I'm going to press enter, and it's going to ask us to read the terms of service because we need to agree to it. I've already read it before because this is not the first time I'm doing this. So I'm just going to type Y, and it's going to be saying, would you be willing, once your first certificate is successfully issued, to be all that kind of stuff. I'm going to put Y again, and the account was registered. It's requesting a certificate for our API, and hopefully it's going to work. And then when it's done requesting, we're going to have a okay, it's deploying the certificate. Perfect. Now we have successfully deployed it, and we can now, instead of making a request to HTTP, we can make a request to HTTPS. So when I save this, this might take a bit of time to propagate, but let's try again. I'm gonna go to Jennifer 4, create another user, and as you can see, we have successfully done it. So this is pretty much it for this part of the video for deployment. We have successfully deployed our app using Hostinger. We have a VPS running. It's healthy. We've done everything related to keeping it secure, keeping it organized. It's not going to run into issues. It is going to be respected by anyone because it has the certificate, and also it is good because it doesn't require you to put any extra ports into the domain when you actually make the request. Now, while you're building your apps, again, we've been using Requestly for this video, and I really want to thank them for sponsoring this video because it is a really good service. I used to use Postman, but honestly, I felt like it was such a annoying setup compared to how easy it was to set up Requestly in my computer. Also, when I used to have a worse computer, for some reason, having to manage the space in my memory for the code that I was running and also a big software like Postman was very annoying. So having a lightweight solution such as Requestly is really good. And to be honest, even though it's lightweight, I find Requestly to be just as or even more powerful than Postman. There's a lot of stuff that we didn't even get to play around with in this video, but you can actually store your workspaces and your different endpoints in the cloud so that you can share with your team so that all of you guys have the same kind of requests set up for your project if you're coding with other people. You don't need to log into your account. I didn't log into my account over here to create this. I bet you didn't as well. And if you already use an alternative such as Postman or Insomnia or something like that, you can actually very easily copy and import everything that you have set up on those into Requestly so that you can switch to Requestly if you enjoyed their product just as much as I did. So thank you so much, Requestly, for sponsoring this video again. And thank you so much for watching this video. This video was pretty long. I haven't made a backend video in a while, and I really wanted to make a backend course because a lot of you guys have been asking me. So if you enjoyed it, please leave a like down below and comment what you want to see next. Subscribe because I'm posting every single week, and I would massively appreciate it. And I see you guys next time.